looked into it any more than like high-level overviewing the docs and going. Over your
we need audio.
Is this another room with no audio?
I don't know.
Let's see. There's a lot of shit in here. This one.
Are there any last-minute volunteer roles that help you guys out today?
Yeah, we could talk to Salt.
Okay.
He knows what we need most.
All right, where can I
The
find
mouse is
him?
working again.
The mouse is working again. Great. He is currently on the first floor talking to an older gentleman while inflating a giant seagull.
Got it. Okay. Sweet. I'll try and find him after this one.
Thank you very much. Oh, right.
Is this working? That does not look right.
It's just because the aspect ratios are a little different. It's okay. It doesn't have to be perfect.
Okay.
When you say that there's a clip art,
Wait.
then it shows up for you to be able to use.
Are we using ALSA audio capture?
No. We're using
Pipe art? Or not pipe art?
Okay, we're good.
And this is used.
stereo for local audio. There, you got it.
No, well, what with this?
Alright,
We don't want this.
Is that what this is? Hello. Oh, yeah, that's not.
Favorite ones to
So when this happens, you have to open up Pavu
symbols
and figure it out in there. All right.
Alright.
I'm going to pull this and plug this in. Where's this HDMI cable go?
We have no idea.
Okay.
This one
I'm just
is
going to shove it in there so we don't think that it's ours.
yeah.
This is HDMI input. Alright. Do we have... This is very soon we're supposed to have... you. Forget.
Yes. So this is, I can present from here or anything else you want?
Yep. Wonderful. Yep. Would you want to set up?
Sure.
Great.
Okay.
So this comes out of here and goes into this one.
Yeah, that's what we were missing.
Yep.
Yeah.
And then this goes into your laptop. And we have adapters. Okay, great. Here you go.
Unless you want to test yours.
Nope.
Okay.
It should be
We had to change this.
that's fine. Oh, okay, so we have it there. Okay, I think we have to stop the stream. Start the stream again. And oh, it's a screen capture. No, we don't want a screen capture. Oh wait, this is for the MPV room, huh? Oh, no, this is local live. Okay.
No, we had to change this. This was empty initially.
Okay.
Yeah.
This is the laptop that didn't get used yesterday. So what we do is we need a video for Linux 2 capture device, and then we pick whichever one of these works. Oh, that's not it at all. That's also not it. It should be this one. So are you sending anything?
Not right now.
Okay. When he plugs that in, it should just work. In fact, we can test it with my laptop. Pardon me. This goes into here. And, yep, great, it works. Cool. So, when you plug your laptop into that, you are live. That microphone is good. All right. Next room.
Thank you much. Professionals. Which screen does he want to be on?
That's always an excellent question. Of course.
So now is none of them. I'm still not seeing anything.
Probably do that. just for safety's sake.
I'm seeing the other
I know
screen.
I'm just gonna reboot the entire computer and have exactly one browser open because we got time, right? It's supposed to start.
Yeah, we have. Can't see the time. Yeah, 10:21. Yeah, we have time. 10:30.
Are we all set in here?
We are having trouble getting the projector.
Got it. Okay.
I'm not sure if it's my computer. I'm gonna just do a reboot real quick.
Okay. Try plugging directly into the computer after you
Hold
rebooted,
on.
just to eliminate the capture card as an issue. I'll be back in like 2 minutes.
Yeah, this is the right one. This is.
So. Yeah, got it.
We're still in the reboot phase.
Cool.
I'm gonna test this really quick.
Talk about effective Git code review. What is my goal for you here today? My goal is for you to make it easy to get your changes into other people's codes, to work well with your direct teams or people you've never worked with before. The best way you're going to do that is making it easy. Make it easy for other people to say, yeah, I see what they're trying to do. Yeah, I see that this code is going to work. I understand the code, I understand the plan, I understand how they got from A to B. It's a valuable thing, it's a worthwhile thing, and it's clear what we're trying to do. One of the worst things you can do is just say, hey, here's 5,000 lines of change. It's going to be great. Wink, wink. We're going to try to show you different strategies to not get into that position where someone says, the barrier for me is too high to even look at your code. Ask somebody else, try again later. So I'm going to sit down first and kind of say, if you are the recipient of the code, if you're working in a code base, what are the tools today you have access to? What are you looking at day to day? So this is me trying to remind you what good can look like and why you want to get this direction. So if anyone's used Git, you've probably used Git log. One of the most important, straightforward things you should be doing this practically every day. Git log gives you a quick summary of who did what when. You've always got a commit hash at the top. Each commit has a hash. It is the unique identifier of that particular commit. When things move around, the commits will change. If you change the text of your one line here, the commit hash will change. There should be some single line at the front that tells you, short, discrete, what this change does. So this I actually pulled from my literal Git repository. This presentation is built in. You're looking at my actual stuff. So apparently a year ago, I committed my 2022 SeaGL presentation in this list. And you can see minor changes I did before delivery. I updated the URL, added the bash completions. So, pretty clear here, just looking at name, date, subjects. If you want to get a little more nitty-gritty, you can actually say, show me a little bit more information as part of that. I would like to see which files they updated. So, there are a lot of different options for Git log. So minus name only is the one I use very, very often. That says, just give me one liner that says what the files were, so I can find out were they editing in JavaScript, or they editing HTML, or they editing Python code. Another good way of just kind of getting information about what those things look like historically. The more stuff you show, the fewer things I can show on the screen. Git blame. Some people might not like the name of this argument, but I find it super powerful. One of my general rules is you're never blaming others, but you're willing to take the blame yourself. So half the time when I'm using Git blame, it's for me to figure out what I did, when, and why. So if I'm working on some code and there's a problem, around line 100, whatever, I'm like, okay, let's just see when that particular line or those lines came from. Git blame looks through that file and shows you the entire file from top to bottom. And on the far left, it tells you what particular commit that came from and when it was done. So if you're trying to figure out, what was I smoking? Was I smoking crack on that Thursday? You can try to figure out where it came from and why. So here I've seen, this was the most recent thing on index. There's the frobnicate change. I mentioned on the previous slide that I was making a change to frobnicate, and you can see it kind of shoved way far over there on the right. You can actually see those lines, and I highlighted them here in orange to make it look clearer. So first part of it is the commit hash, and then the date in the middle. Git show. This can give you a lot of output depending on what your commit was. It starts off like a lot of the other ones did already. It shows you who made the commit, what the date was. It gives you the full list of what the commit message was. In this case, it was just one line, post-delivery updates. and then it starts giving you a diff format. If you're not familiar with diff, you're going to be when you use git enough. Super short version is, diff output comes in a variety. Typically what I do are what are called unified diffs. This is a unified diff. It is showing in a unified manner what was and what has changed. So any lines starting with a minus sign, those are what was in the old stuff. That's the stuff that's been removed. Any lines that start with a plus are the ones that have been added. Those are the new lines that were added into this change. And a unified diff tries to keep those things as close to each other as possible, rather than showing, here's the first version of the file, and then 20 pages later, here's the complete second version of the file. It tries to keep those things as close as it can to make it easier for it to do. There are also plenty of other tools you can use. You can do three-way merges and different tools that will pop out where you can do left to right. I typically am in a command line, and this one is the easiest way for me to do. But again, these are the things that when someone is looking at your code or looking at your proposed code, they're going to be working with. So now we've seen what people can do. Your job in your efforts to get your code committed to some third party or to your team is to make it so they don't have to do so much of this. You don't want them to say, let me do a blame, let me do a diff, let me try to figure out what all this stuff is, because the guy gave me a 5,000 long line change, half of which was just changing indentation, and some of it was just making this little 5-line thing a function. It got moved around. When you got a big, huge blob of stuff, it's off-putting. It's overwhelming. So try not to do that. So here are some of the simplest tips I have for you. When you're making commits, make the commit message meaningful. Make it explain what it does. Try to make it so that they don't have to do research and go spelunking down here to find it. Concise changes. Don't make the one big 5,000 line commit. Make 5 of them and make each one kind of its own functional unit. For example, let's say you have a piece of code that you wrote, and then you're working on adding more stuff to it. You realize you didn't want to call that code again. Oh, I should make that a function. That'll be better if it's a function. Well, if you make a separate commit that just takes those 10 lines of code, moves them into a new function and calls it, make that a single commit, it's very clear. They can see this was just copy and paste. If you then update that function, as a failure commit, you say, oh, now they're evolving that function. Great. But if you started it, moved it, evolved it, and then put that in the middle of a bunch of other stuff, then they have to figure out, well, okay, how many real effective changes went through this? So try to keep those things small. Even if it seems like it takes more time, it makes it easier for people to understand. Consistent style. Things are easier to understand if they look like what you're expecting. You want to have your expectations fulfilled when you're looking at this. If I'm reading a whole bunch of Python code and it looks the same as the other Python code around it, that's the kind of goal you're looking for. Linear code evolution. Not required, but sometimes it is really helpful to put things in the order that they make sense. So again, when you take the function that wasn't a function, make it a function, make it small, then you update the function, then you work on the things that are calling the function, individual commits that show like an overall evolution that looks like it was designed, if you will, even if that's really not how you did it in the first place. So let's talk about those commit messages. I'm going to get a little anal retentive, and there's a reason for it. Your commit message should be consistent, and it should follow this format. This is just general best practice. The first line is one line. It's one line, and it's short. It is not long. It is in the declarative present tense. You can kind of think of this being as after the word, this commit will, insert message here. So, for example, this commit will frob the widget, update the food, delete the documentation. It will something be very active declarative. Do not make it huge and long. If you can't figure out a way to make it short enough to be descriptive because there's too much change, maybe that should have been more than one change. So use this kind of as a forcing function. If your commit message is updates the widget and makes the widget green and does this and does that and does that, well, those maybe should have been broken up. So you've got one line, blank line. If necessary, put some description. Here's where you can get really freeform. You can say, make sure that when you take this change, you have updated any of your code that calls the new frob indicator. It could say, this radically changes the inputs for this thing, but I'm pretty damn sure I've updated everywhere that it's called from. Boy, I wish we had unit tests. You can put as much description in here as you want. You might want to have a reference to a GitHub issue, a GitLab ticket, something like that also. That's fine. That's great for being able to associate it with things, and some tools love it when you do that. If your ticketing system and your code system are integrated, then a ticket number will be able to be clicked from your code and back to the ticket and vice versa. But don't just say, this fixes bug 123. Because then somebody's got to go to the ticketing system and figure out what bug 213. Maybe they only have access to the Git repository. So you can include those in there, but don't make them the documentation. Some people go with the 50-72 rule. Your first line should be short, say 50 characters, and the inside of it can be 70 or more characters. But try to keep it such that it sticks within a single window. You're welcome to use, typically in the first line, some acronyms as long as your team agrees on them. NFC is a good one. Means non-functional change. That kind of tells somebody this is not making anything that's going to really change the code. That doesn't mean I refactored this thing and it still works exactly the same way as it did before, I promise you. It means I'm really sure it doesn't make a functional change to the code. For example, the help output used to not have anything for the -- frobnicate option, and I added some more help output, right? There's no functional change to the code, but maybe you put that extra dot in some documentation or in a doc stream. I personally will often use WIP, work in progress, for stuff that I know I'm planning not to commit later on until I do some refactoring, so it's a way for me to keep track of it. So here is one line Git log. It'll show you just the Git lines itself, that first line. And here is how not to do it. So working from the bottom up, the oldest stuff. From Doug review, what did they do? I don't know, it came from Doug. Make code faster. Boy, that's helpful. Fix bug 8675309. Anyone know whose bug that probably was?
Bug.
That was Jenny's bug. Anybody not get that? Yeah, okay. I've seen all these, by the way. Shit, fixed. Fuck. Finally fixed. Adds another layer of redirection to the Frobnicator widget. Factory flow, it's way too long. You can't keep track of that. Pushing on a Friday and broke the prod again. So you want this to line up. You want this to be consumable to get an idea of what's happened. This does not work. Again, this is my actual Git repository this presentation's in. Fix some lint issues. Here's an NFC to convert to 4 spaces. Adding presentations, done. This gives you an idea of what happened. This is what you're aiming for. Okay, so this is a longer version. Covers much like I mentioned. Very, very bottom here, I've got a reference to a ticket number. So good style here. Okay, when you're updating somebody else's code, match their style, even if you don't like their style. If they like to have the curlies here, or they like to have the curlies there, just match their code, make it pretty. If you do decide that you want to, say take a 2 space indent to a 4 space indent, don't do it in the middle of a change. Make a complete change where you go from 2 to 4 spaces, and get a approval, and then do that, and no other changes inside there. If they like tabs versus spaces and they won't accept your change, wait till they're on vacation, then do a tab to spaces change and get somebody else to review it. When you're starting code, pick a style. So we say our curlies go at the end of the line or they go at the following line. Pick a style within your team. Mention when you're reformatting, separate your actual just format only changes from the rest of it. Consider using code formatters. Black, I love black. I know there's one person in this room who does not. I love him too, but he is turning the other way. Black, if you've ever bought, remember the story, you can get a car in any color you want as long as it's black. That's where the name comes from. Black will format this code the way it wants it to be. And if everyone runs black when you're done, everyone's code will look the same. Golang format, if you're not using that, you're probably going to get a lot of Golang people who don't like it. Type hinting in Python, good idea to make it easier for people to see in your stuff. What you really want to do, if you can, is force the issue. Put these checks inside your CI/CD pipeline, so if somebody did not run black, if somebody does do things wrong, it'll say, you can't commit it, sorry. So here's an example of before and after running black. So this first one, the line was too long. The CSV writer is wrapping all the way across the screen. Oh man, my little 8-column long terminal doesn't like that. After you're done running black, it says, here's what it would look like. So you can run black with a minus diff mode. Or you can just say, run it. So here I gave a minus L72. I said, let's be 72 characters long. I don't remember what the default is. I said minus capital S for those people who really have a passion about single versus double quotes. Black is passionate, and he might be different passion than you are. So you can say minus cap S, please just let me use the quotes I like. So when it's done, it literally will just reformat your string. Boom, you're done. Commit. So let's talk about making yourself look smart and making it easier for people to understand what you do. So we're all going to have a reality check here. We do not take that 2-line thing and make it a new function and commit that, and then evolve that function and then commit that, and then do this and commit and that and commit. And it does not ever come out the way we thought. We ended up putting a whole bunch of print and logging statements third way through, and we're like, yeah, there's my embarrassing smelly poo, but it was the only way I could debug this stuff. You actually can use the fact that Git is amazing / scary to refactor even what you had done in the past. So we're going to talk about some cool strategies to fix up all of that. So here are the tools we're going to work on. First foremost, you have to remember to make a new branch before you start screwing with what you got that worked. So git checkout -b, make a new branch from what you got. Git add -p we're going to go over. This allows you to add selectively stuff that is currently not committed. Git commit amend allows you to add to an existing commit that is at the very top of your list right now. So add in some more minor changes. Maybe you delete that logging line. And then the big fun scary one, git rebase -i, allows you to say, let's look at the last 10 commits. I want to refactor them. I want to reorder them. I want to delete some of them. I want to squash some of them. Git cherry pick similarly can be used along that. Worst case, you can always go back to your original branch. If you do something irretrievably horrible, you can use the git ref log. If you need to do that, things have gone very wrong, call a friend or clone and start over. So I went to ChatGPT and I said, write me a program that will read 2 CSV files and merge them. And it gave me back some code that was like, eh. And so I committed that. And I said, okay, now I'm going to go on and play with it. I'm going to try to clean it up and make it a little bit better. So working from the bottom up, that first commit, add code from robot, that was the one that ChatGPT gave me that, it works, but I didn't like it. And so I made these changes, but they were kind of ugly. I got one called merge me. I got to fix up, please. I was going as fast as I could, right? So let's see how we can try to clean that up. So here's a git diff. You'll see right now we've got the first section here. I have changed simply the doc string. And down further on, I've made some significant changes to how the readers and writers are pulled out. I would like to split these up into smaller changes, right? So I don't want to just commit all this at once. So I'm going to use git add -p. I want to have just one of these chunks, not all of them. So git add -p is going to do an add, and it lets you see what you could potentially add to be committed. And it gives you an option. It says stage this hunt, and it's got a bunch of letters after that. Yes, no, quit. So we're going to say skip this first one. First, what it did is it showed me everything, it showed me the entire freaking file because I made so many changes. S means split this into smaller chunks. So instead of a huge thing, I'm going to split it into smaller chunks, and now we start seeing individual things. I see this import line was added. Do I want to include that chunk? I'm going to say no. I really want to just fix that doc string, right? So I'm going to skip that one, so I say no. Bottom section here, it says here's the doc string change. Do I want to include that one? I say yes. This is the full list of things you can do with git add. So I've said I want just that doc string change. And I said no and quit to all the rest of them. Git status, you can see that there are 2 pending changes. The top one is what I've staged. The bottom one is everything else. When I do a diff cache, it would show just that doc string change. Then I can do a git commit -m to commit just that doc string change, and I can commit the rest of it all together. So adding things incrementally. Git commit -amend. If I made one last change that's related to doc strings, maybe I just commit that right away without needing to make another commit. Here's where we get hairy and fun and exciting. Rebase -i. So how far back? How many changes do I want to look at? I'm going to rebase them. It gives you a list. It drops you in your editor. Your editor is VI. Otherwise, find a different conference. So we've got different things, and this is what starts off with pick, commit name, one line message. This is why those one lines have to be one line. You can reorder them to put them in different order. You can delete them if you want them to go away. You can squash them together, so put 2 things in a row and squash them together. So you can do lots of stuff to clean it up. So in this case, I want to move the description of read CSV change. That was just our our doc string change, I'm going to move it up to the place that we wrote it. Why do we need to have a separate commit that just changes the first line I made for my doc string? So that will squash that line into the one above it. And when I'm done, it just rewrites it. In this case, I go to edit. Say, I want to edit that entire commit. And so here, when I do a git status, it's going to, I hit enter after exiting my shell. It's going to show me that I'm in the middle of a rebase. Git status shows me where I am. Here are the changes you started with. Here are the changes you're on. I'm on no branch. That feels real scary, but it's okay. I'm going to reset. I'm going to say, okay, so I've got a commit that was fine. I'm going to reset up to where it was before it was cached, or before it was made. I'm going to manually add bits. So I'm going to add minus p little individual chunks. So here I make a read CSV generator as a single commit, and then I do the rename of, or the commit that renames the left and right files. Because I put those in together by mistake. I shouldn't have done that. Then I finish my rebase. When I do get branch again, I'm back where I started. And so I've split those into two things, even though they were in my history like 7 commits ago. And now I have a prettier version of the history. So now the person who's going to be looking at this can kind of follow what I was doing. He doesn't see, update this, but it actually had two separate unrelated things in there. This is a picture of where I have got the project in GitLab. You can now see prettier list of commits over there over time. The old one. This is the prettier one. The text is broken up a little bit better. One thing I will suggest in Money Tools, when you go and say, show me the diff, it likes to show you all of it. Even though I had like 8 changes, it shows me a wall of words. That's why it's so small. We can't even see. Usually what you can do is you can hit previous and next. You can go, take a particular commit and look at just that change, and then go from that one to the next one to the next one. And that way, as a reviewer, you're able to see clearly what they were doing. So here, this is just the making paths change. If I hit next, this is just the change to make a generator. If I hit next, I hit just the change to rename the file names. So that is how I try to make my coworkers think I'm smarter than I am and be more likely for me to get my code committed to them. And when I go back down the road and I need to find out who broke it, and it was probably me, it helps me out too. So I hope everyone had a good time. Any questions? Yes.
How do you feel about Git hooks?
I love Git hooks on the server. CI/CD is pretty much all Git hooks, one way or the other. I do not typically have them on the client side because I know they're going to run on the CI/CD side, and there's no way to my knowledge when I clone something to get my hooks, so we can't all share the same Git hooks when we check it out. And if I can't guarantee that you and I both have the same thing, that makes it trickier for me to know that I'm using the right stuff. If anyone knows of a way to make sure you and I both get the same hooks when we clone, I'd be very interested. Yes.
Merge versus rebase.
What's that?
Merge versus rebase.
I like the rebase interactive because it looks pretty to
I
me.
just mean like if you're merging like a BR.
I'm not touching that one. No. No. We're not touching Holy War stances. Merge commits versus yeah. There was a question over here too.
Second guessing myself. I was just going to say on the GitHubs matter, you can put your GitHubs into a Git subrepo, but that way lies madness.
For anyone who couldn't hear the question, you can put your GitHubs in a subrepo, and that way lies madness. I would agree with both of those statements. Awesome. Thank you for our tech folks here at SeaGL. Much appreciated. Yep. And everyone, go enjoy some more talks today. Thank you much.
Yeah, we can all certainly learn how to write better commits.
very much. Hello, everyone. My name is Alex Byrne, and this program is What's the Ideal Giveaway Computer? So if you're in the wrong room, you still have an opportunity to flee, and if you're watching the wrong stream, you have the opportunity to flee. I'm a youth services librarian with the Pierce County Library System. That's the county that surrounds the cities of Tacoma and Puyallup in Washington State. At some point, someone's going to ask, what's a librarian doing at a tech conference talking about things? So, I thought I'd give you a little background on me and the things that I've been doing. I've been a relatively privileged person in my life in that, even from an early age, I've had computers all around me, in my room, in the family area, and I did a lot of learning about computers, usually in service of trying to make video games run better. This is a common thing, I'm sure, for most people who are here. But that's what it did for me. I learned things like changing boot environments, messing with environment variables, learning how to free up memory because someone is alleged to have said that 640K of memory is all we'll ever need. As well as using Windows managers, managing terminate and stay resident programs. So basically ever since like DOS 6 or so, through the Windows 3 series, and then when they started using Windows year names and then decided that was a silly idea too, I've been doing all of this. And most recently, I found myself at administering Linux systems as well, because apparently once you start doing technological things, you don't stop. Well, especially if there's something new and shiny around the corner. As part of my professional life, however, my organization is interested in trying to help out lots of people who are, we use the acronym ALICE, Asset Limited, Income Constrained, and Employed People. These are generally people who don't have things that they can save for retirement with, or who have houses that they can draw money on. They're usually renters. They're often, they don't have a whole lot of spare cash as well. For unexpected emergencies or expected emergencies, but they are employed, right? Often working more than one job at a time. So when you think of ALICE people, you kind of want to think of the line between where the federal poverty level is, the line that's established by the federal government as to if you are richer than this, then most programs you're not eligible for, but not enough income to the point where we would say that they have either a living wage or can live comfortably on the wages that they are giving. So, asset limited, income constrained, and employed. Those are the people who I am mostly trying to think about when talking about giveaway computers and other technological things and library services. That's for the most part, people who are in the ALICE space and around. And generally, they have access to computing, but they do not have access to computing in a way that is particularly open or free of encumbrance. So there may be a one laptop per child in the school, rules for all of them, because that's easier to work with. But that computer may be a Chromebook that has been worked on by the IT team, so that it has locked functions, it does not have its full availability to it, that there are things that a student can't do with them, and often these things come with spyware or boshware or other sorts of things that are meant to also make it easy to log if someone does unexpected or malicious or unintentional things with the device, and then consequences follow. Well, for adults, they often have the same thing. They may have a work-issued laptop, and especially in this sort of ongoing pandemic era where remote work has suddenly become more feasible than it would otherwise have been, people have company-issued laptops as their computers that they can work from home with or in the office with, but they have the same problems. Because someone else controls the device, they are often function locked, and they also tend to have things that are spyware or boshware or other things on it so that the company can spy on the worker and make sure that they are doing what the company believes is appropriate use of their resources. The third problem space are not necessarily people who are employed, but people for whom their younger relatives have bought them a device dropped it in their lap, said, "It's intuitive, you don't need to learn anything about it," and then vanished into the ether, thinking that they had done a great deed for the person that they had just given something to. This is wrong, and we'll explain why a little bit. But a lot of these, intuitively easy, or in the significantly offensive parlance, so easy your grandma could do it, that was thrown around a lot. Trust me, if you've ever met plenty of grandmas, that's not the phrase that you want to use for that. But they also get these sort of limited locked devices that either have to have an app store to work with them, or that otherwise don't allow for greater access to the machines themselves, and are often forcing someone to conform to what the manufacturer's idea of appropriate use of a computer is, rather than whatever someone would like to do themselves. Thus, most people lack a device that they can control and gain technical and other proficiencies on. We want to fix that. Right. So, these are our target audiences: mud-spattered children and tweens who have been told that they are digital natives and therefore they require no education at all about how to use computers because they'll just pick it up. They've been with it all their lives, they'll just know. Oh, and adults who are looking for additional skills, possibly to help them get better jobs or work in sectors that they would like to but don't have it. And those seniors who have had that device dumped in their lap and then just told, well, it's easy, you'll pick it up without any need to have any instruction about it. Okay. What I want for them is to have a giveaway computer, something that we can just hand them and they will be able to use. Now, there are some requirements for this if I want it to be able to work. It has to be inexpensive. After all, when you want to encourage someone to do potentially dangerous things with a computer, the last thing that you want is for them to risk their $750 laptop on this sort of thing. We want very inexpensive devices so that we can encourage experimentation and the learning that comes from blowing something up and having to fix it. We want it to do certain things. I call it a general purpose computer because what I don't want is a device that's really more of a toy or a single use object. I want something that can edit text, edit still images, watch videos, browse the web, anything that you would expect a modern computing device to be able to do. I also want it to be able to play some games because not everything should be serious. Now, that doesn't mean it has to be able to run, Baldur's Gate 3, but it does need to be able to play some games. I don't necessarily need it to be able to multitask those things. It's perfectly fine if you have to close out of the text editor to open the image editor and then close out of the image editor to open the text editor. That's fine. And in an ideal world, what we want to be able to do is, if it breaks, that it can be fixed. Whether that's the hardware has broken and we need to fix that either by replacing a component or learning a little soldering, or the software has broken and therefore we need to figure out how to patch it or how to unmess up whatever process we have started to do. Now, on top of that, I would also like, these are not requirements, but they're nice, if you have user accessible hardware, because then you can actually learn about the components of the computer. And even better, if it's user upgradable hardware or user swappable hardware, that extends the longevity of any device far beyond what its initial process is going to be. I want it to be portable because sometimes the best learning that ever happens is when you and a friend get together and go, hey, this weird thing happened, or hey, I want to do this cool thing. And when you have people who can use their computing resources together, it often results in cooler things happening or learning that goes on. And I want it to ideally cost less than $100 to be able to kit the thing out in its entirety. So not just the board being less than that, but board, keyboard, mouse, any accessories that go along with it. I want it all to cost less than $100. That's a nicety because I'm pretty sure we haven't quite made it there, but that's the target zone that we're aiming for. So, you probably have some ideas in hand as to what might make a good ideal giveaway computer. Or some people, they go, well, we've got these lovely inexpensive desktop machines or these single board computers like Raspberry Pis or Orange Pis or Banana Pis or Le Potato. Well, there's a big fruit and vegetable theme in single board computers, it turns out. They generally work if you've got a screen to go along with them. And a 2022 Nielsen study says that the average amount of TVs in a U.S. household is a little more than 2. So even if there is someone who uses one television exclusively for television watching or other things, that usually means there's another TV somewhere that could serve as a computer screen. And screens are expensive. So if you've already got one, then maybe all you need is a little bit more. So, and for those, I'm thinking the sort of contained single board computers, the Raspberry Pi 400, the Orange Pi 800, that take their example from the Commodore 64 and other such older computers, completely housed, just a couple cables out, and away you go. That's way better for portability than the standard sort of, okay, now you've got the Raspberry Pi board, and you need the case, and you need all of these cables and accessories and things to come out of it. But there's also the possibility that you could save some e-waste by using repurposed Chromebooks or other laptops as well. I specifically say Chromebooks because they have a shelf life on them. 10 years after they first reach the market, they're discontinued. The hardware may still work just fine, but they will receive no additional software updates. This is Google's decision. But using some technology and a few scripts, the one that I'm highlighting here is from Mr. Chromebox, a user. You can, so long as you know how to disable the firmware write protection on a Chromebook or a Chromebox, you can overwrite it with Core Boot and then install Linux on it, or Windows, depending on how well it's supported. Like this computer that we're running this presentation right now on is in fact a repurposed Chromebook in just such a way. However, as we'd love to have an ideal computer, we can't get everything that matches all of our requirements and all of our niceties. The portable things are often not user upgradable and serviceable. The user upgradable serviceable things are not portable. Some of them are more expensive than others. So we have to kind of, you have 3 options, pick 2. So, and for each person's case, that's going to be slightly different as to which of those will work best for them. For what software we're going to put on it, well, if we want it to be cheap, it's going to be Linux. Windows licenses are extremely expensive, and unless you have someone who has either volume discounts that they can go away with or a valid student price, you're going to price yourself completely out of inexpensivity by trying to put Windows on these machines. And sometimes it won't work, depending on what it is anyway. But which Linux? And, other than inciting a complete riot about, which distribution is the best, there are too many choices for this, for someone who is just coming into the technological world to go, well, which Linux do I run? That's a great question, and we don't want to force someone who's just getting in here to have to make that decision. So somewhere along the way, we're going to have to do some sensible default decisions. Ideally, what that would be is like a live image with several distributions on it so that someone can test them out and decide which ones they like. But there are some problems that come along with that. More specifically, of the ones that are beginner-friendly, and in this case I sort of use DistroWatch's proxy. You can yell about me about my poor choice in websites later. If we're talking about the installed memory on, say, a converted Chromebook, out of the 9 or 10 that they say are beginner-friendly, only 3 of them will fit in such a way that there will be enough space for user-generated content. And then that's assuming that there's a 16 gigabyte internal memory module like the one that I have. As we progress, I'm sure the memory modules will go up to 32 gigabytes in the later generations of Chromebooks, which means that you get, 4 more that can join this. I can put this on here and still have room for user-generated content. But if we're talking about, low memory sorts of things, there aren't all that many options. If we use single board computers, we have a similar situation where, an extremely inexpensive 8 gigabyte SD card will give you 4 possibilities to work with, one of which doesn't have a graphical interface at all. Oh, and if you go up to 16, then you pick up 2 more. So we're definitely, there are people who like working with low power, low storage materials and building distributions for them, but they generally don't build very beginner friendly versions of it, because when you are sacrificing a whole lot for space, there's a lot of complexity involved in that. And all of these things that we're talking about that are doing are not necessarily things that we want to have someone have to do all by themselves. Things like, flashing images or disabling write protects or changing boot orders in your BIOS. Those are all highly technical activities, and people who are not familiar with computers do not do those things. Not without good instructions and possibly someone holding their hand while they're doing it. So most of the computer users that I deal with, especially when they're coming in for me to fix problems, they are terrified of computers. They expect that a missed click will cause something, they'll get hacked, their bank accounts will be drained, their identity will be stolen, and everything will be spread across the internet. I only exaggerate very slightly in this. But if there's someone there next to them who they trust knows what they're doing, they actually can do plenty of things. They just need the support of the person there to assure them that they're doing the right thing, or when they're about to do something that they don't want to do, to point out to them, hey, you said you wanted to do this. The thing that you are doing now is not that. What do you want to do? I want to do this. Then you need to do this instead. And so a knowledgeable person is often really helpful for that. Okay. That said, I and my colleagues will curse you to the 7th generation if you decide that we don't need to do any of this. The public library handles this kind of stuff all the time. They do tech support. They have tech programs. They can do it. Don't you dare. Because while I am technically apt enough to do a lot of these things, not everyone who works in a library is, and that creates frustrations. And secondly, we should not be first-tier tech support without getting paid for it, damn it. So, don't. We'll help you, but don't do it. Don't just tell us to do it. Now, if you have a grant somewhere that says, hey, we're going to train your entire staff up to the level of being able to do this, okay, if you're going to pay for it, we'll let you. But you better have that money in hand if that's what you want to do. So, there obviously will need to be support that comes along with it. And that's almost as important as the device itself. So, there is no ideal giveaway computer. I'm sorry, I know I teased it with the question and then I'm giving you a non-answer. There are good candidates, though, depending on the situation that you're in. Whether it's a single board computer, or a converted Chromebook, or a hand-me-down laptop, or a desktop. It depends on the person and their situation as to what they're going to do. And in addition to the actual device, we also need to have a support structure in place for these people so that as they do their learning and becoming more technically proficient, there is someone there that they can ask questions to. Or say, hey, I want to try doing this. Is it possible? The answer to that is usually yes, but you have to know how. And if there's someone who knows how, that helps things all along. Even when we want to encourage, like, experimentation. Yes, it's possible. See if you can do it. I kind of blew the machine up and wrecked the configuration. Okay, now we learn how to reflash an SD card so that you can start again and try again. These are all important skills for someone to learn about computers and computing, and they really do need someone there to just sort of be there for when the inevitable explosion happens. I learned so much about computers and computing and messing around with settings by trying to do a thing, having it fail, and then figuring out how to figure out, okay, how did this fail? Well, what went wrong? How do I fix it? And this is in a pre-internet era, so there was a lot of experimentation that went on with that. This is a Creative Commons licensed talk. Feel free. Please do attribute me. I'll show my socials and other things again if you choose to use this or things from it. I also ask that you share alike in that same way. And really, if you do this, please let me know. Like, I'm always thrilled to hear someone says, yeah, this thing that you did, I used it and it was useful. Oh, so, the answer to what's the ideal giveaway computer is, it depends. But hopefully now, after having listened to me for about 20 minutes, you have a better idea of what it might be and how you might go about handling or finding ways of making it work. Okay. Thanks much, everyone. I have time for questions now, if you have questions to ask. And if not, I'm in Element for the chat at the conference, and you can contact me on Mastodon as well. The address for it should be pronounced glamorous. That's involving galleries, libraries, archives, and museums, for those of you who are not familiar with the GLAM acronym. So, are there any questions about this? Please.
I'm currently in Seattle. I'd love to be able to volunteer and do this kind of work locally on an app. Do you know if there's like something on Seattle for this scene that's like built here?
The question is whether there's something local to Seattle about volunteering or doing this kind of work. As far as I know, no. Oh, but when I say as far as I know, no, what that means is if you're interested in doing it, that means there's nobody else that you have to deal with for it. And so that's entirely possibly, it may be that there are no organizations that do this, and you are the person who is going to make it happen. Are there other questions?
We're getting a question from chat.
Chat?
But it's not ready yet, so this
okay.
person's typing.
It's nice having that up as well for people. Yes?
Where would I get my hands on a computer?
The question is where can I get my hands on a computer to repurpose, like an out-of-service Chromebook? Actually, the place that you're probably going to find it, if you're in Washington State, is the state's property disposition space. That handles all of the selling of assets that have been decommissioned from schools and other public entities, and they often sell them by lot. So you might end up having to go, well, what's available is a pallet of Chromebooks, 50 Chromebooks that were all decommissioned from one of the local school districts that's available for some nominal amount of money. You'll have to go to Olympia to get it or arrange for it to be picked up and shipped to you. And I wouldn't expect like all of those Chromebooks that come through to be perfectly in working order. I expect some attrition because they've been used as school things. But that's probably your best bet in terms of finding a whole horde of them all at once. The one that I got was being sold on an Amazon affiliate during a sale for it. So, and having done it once before, I felt much more confident in doing it again to a different model of it.
Okay, we have a question from Matrix Chat. Have you ever tinkered with the Lychee RV, which is $10 but has no mouse and keyboard?
I have not. In fact, continuing in the fruit theme, as I know, a lychee, but I have not worked with that particular board. Given that it also doesn't have a mouse or keyboard in it, like those are inexpensive accessories. I'm not saying that it's, but usually boards that require accessories lose some of their portability with them. Like you can carry your mouse and keyboard with you, which is great. But if you want a portable, compact, all-in-one sort of space, if it's something that requires a keyboard and a mouse, that's extra cables and cords and things, and that makes it less portable. Still might be a good idea. And if it mates all of the ideas of what we want, great. Right. And that's why I say, especially for those that I want the whole kit to be less than $100, because sometimes the boards are very inexpensive, but then you have to do all the other stuff that goes along with them to make them actually functional computers. And that can get expensive quickly, as I'm sure plenty of people who have dabbled in single board computers found out.
Okay, I think we gotta wrap up.
Thank you very much. Thank you. I'm here at the conference and on socials at all of these times. Thank you very much.
afraid not. But the mic should be picked up.
As long as I'm just
Yeah.
projecting something.
Yeah.
Okay, that's fine. I just want to know where I should and should not.
Alright, we're ready to go. I think it's not quite full screen.
Yeah, what happened there?
Okay, thank you.
All right, Butterfinger. Thank you. Starting out spoiled. All right, everybody, we are going to get started. We're at about 11:30 here. Maybe, that's all right if more people are trickling in, but we'll go ahead and get started. Welcome to Diagrams as Code. This is going to be a hands-on introduction to mermaid diagrams. If you know what mermaid is, great. That title is helpful. If you don't, then hopefully you will by the end. My name is Cameron Bilstein. I am by day a software engineering manager at the Allen Institute for Brain Science, but nobody cares about my day job here. Here's the right slide for everybody. I am a open source developer and maintainer of some super niche projects, mostly amateur radio that I think might be used by me and maybe 3 other people in the world. That's my correct title for I think for here. So nice to meet you. We will go ahead and dive in. So agenda, I'm going to talk a little bit about documentation and diagrams. There are whole novels and all sorts of academic literature on how to write good documentation and what makes a good diagram. I have 20 minutes plus or minus 5, so we're going to skip that and go into an introduction to Mermaid. We're going to pull up an editor and code some stuff and tinker with some diagrams. I'll close with a couple of tips, and we'll finish with Q&A and discussion. So documentation, right? We are, I think most of us are probably familiar with the READMEs that you'll see in open source repositories, or hopefully closed source too. Hopefully there's documentation in all the code you're reading, but not always. Best practices are, you include in your READMEs, you're including information about, how to use the project, how to install the project, how to bring contributions to the table, whether they're code or bug reports or whatever. The reasons that we write this is for ourselves as maintainers, for our users, for any contributors. And there are a couple of studies that actually show that good documentation actually attracts contributors and attracts users by lowering barriers to use and learning your software. I'll pause and note I've got a bunch of citations in here. There's a slide at the end that shows bibliography, but we're in a school, so I figured I've got to cite my sources. Otherwise, it's academic dishonesty, I think. So, cool. So that's READMEs. However, they're usually only in text. This can make it kind of hard to convey some complex ideas. Diagrams can help with that. Now, there are some people who are, prefer text, some people who are super visual. So, both is a good option. But if you're like me, sometimes looking at a nice technical drawing or diagram can convey something that a page of information just doesn't quite convey that sense of knowledge ownership. So, how do we go about adding diagrams to our documentation? I've got a couple of examples here that we'll run through and talk about their pros and cons. So the first one is just you could draw it in text, ASCII art, a good old-fashioned classic. This citation there, number 4, is actually this great study of Ubuntu contributors and developers, how they communicate through their documentation. The authors of this study went into how they, this was, an older study, 5-10 years ago, as I recall. We'll see if I can remember that correctly at the end of the bibliography page. But a lot of them actually defaulted to using ASCII art because they couldn't find a unified toolkit. But at the same time, they complained, like, wow, it's really hard to draw this out and make sure it stays formatted. So the pro here is anybody who's got a text editor can read and create this stuff, but it's kind of hard to draw out and keep up to date. On the other end, you can just embed some image. Maybe this makes a prettier image. Maybe it's easier to draw out. but if you've ever had to try and redraw or fix something in Paint or GIMP or whatever your drawing of choice is, makes it pretty brittle if the software changes, if you have to change some of your documentation. Or if you've ever tried to, check in a binary file to source control, that's not super great when you're updating. You can go one step further and you can embed a file, the file of the documentation itself. You could open up something like LibreOffice Draw, and then instead of exporting and embedding the image, you just embed the file. But that means everybody's got to have the same tools. Again, versioning a file, depending on the format, is pretty rough sometimes. Versioning of the software you're using. And then there's another option of you can do an online tool. This is pretty popular in corporate environments, something like Figma, which is pretty easy, right? You just kind of click and drag around. Everybody sees the same UI. It all updates. But, a lot of times there's a price that comes with it. There's a network requirement. If I'm sitting in the airport and I want to, I clone the repository, now I've got to get my Wi-Fi out just to see the documentation. Kind of sucks. And you have a dependency. If that web tool goes away, or the contributor, the maintainers turn off their subscription, then you've lost stuff. So it's kind of a lot to say. We like the ease of use of using text, but it's kind of difficult to author stuff out. That's where a tool like Mermaid comes in handy. To some of the pre-conversation in the room, there are other tools that do similar stuff. But what this gets us here for Mermaid is we get human readable. This is all as diagrams as code, so it's easy to modify with your text editor. Your changes are clear in version control, and it's all human readable. But it generates some output when rendered that will look like a nice painted diagram. It's got wide support, so wherever you're hosting your code, a lot of them view it. However you're editing your code, at the very least, a lot of them will have syntax highlighting and tips, which is great. And it's open source, so you can go and check out the code and make improvements. So what can it draw? Here are examples of, maybe half of the types of diagrams that Mermaid can draw. It's pretty versatile. We'll talk about a few of them, but it's there's a lot of stuff in here, right? You've got the easy flowchart at the top left, all the way down to whatever you call that thing on the bottom right is, and all sorts of stuff in between. So you can probably find exactly what you need. So, all right, enough of setting the context. We are going to, let's code some stuff. I'm going to bring up a text editor. We're going to run through some examples. We'll tweak some stuff, and hopefully that'll be a nice intro to whet your appetite to try this more. So let me flip over here. All right. Oh, that's pretty small. Blow that up. Okay, so what we're looking at here, this is Visual Studio Code. I know, boo, hiss. But it is my editor of choice. I've got it set up here to, on the left is our Markdown code. So this is what you would write a README in a lot of repositories. This is one of our, one of the standards. On the right is the rendered code. So, you can see an example here of, my code on the left and then the rendered result on the right. So if we dive in, let's look at first an example of a flowchart. So I'm going to kind of walk you through here what we're looking at. Again, this is code embedded in a Markdown file. So where you see these triple ticks, and this is Mermaid, inside of that is the Mermaid code that we'll talk about. So what I've highlighted there, or really just the inner portion here, is Mermaid. You can see it rendered across over here on the right. So our basic syntax for a Mermaid diagram is you declare the type up top. So this can be a flowchart or all of the other stuff we just saw. And then you declare your diagram underneath that. So here's a super basic example. We have two nodes connected by an edge. So you have a node ID, some edge identifier, and a node ID on the other. So I could tinker with this and add another line here and say C has or B connects to C. I've got to declare them, I guess. Right, and you see that on the right hand we've updated to include a new node. So this is pretty easy. You can see how this is really human readable. You can look down this and put together in your head, oh, I've added a new line, that's what it's going to do, that's what we see on the right hand side. There's all sorts of stuff in this that makes it, you can make fancier shapes and drawings. You can change your direction. By default, it'll render top down based on the flow of your connections. You can change that around. I've got a list here of the supported options, but we can go bottom to top, and you'll see them flip over, or you can go horizontally as well. And then there are a bunch of different options on edges. We can switch to equal instead of dashes. You get a slightly thicker line. Maybe that's harder to see in the back of the room, but trust me, it's thicker. You can add a dot in the middle to do a dotted line, add an arrow on the end. So I think you're probably starting to see what I'm talking about, right? This is pretty easy to read still. The syntax in your text is pretty clear to see your intent, and then it's rendered out. So let's dive down a little more. You can change shapes and add labels. So if we want to add a label or a title, we're going to look at this section here. So above we just had simple ID and then a line, an edge, and then another ID. But if you put after each of those things, you can put some sort of brackets, which will determine the type of shape, and then a word inside of it that will be labeled. So here we've got, square looking our corner brackets, whatever you want to call those. Translates into a square. We've got et cetera, et cetera. So there's a whole list of them. I've listed a couple here of options, but there's tons of them. What does this look like when we push them all together? So here I've done a kind of simple, silly flowchart of how to prepare a talk. See the announcement, you come up with a new idea for the talk, then you've got a decision point. Well, is the idea kind of met? We'll go back again and come up with a new talk. Is it good? You submit it. If it's rejected, you come back up. Eventually it's accepted and you go, shoot, I've got to write something down. So you iterate through. Eventually you'll come out and present. And you can see all of that here on the left-hand side. I'll declare a bunch of the nodes here up at the top in the code. And you can see, again, IDs followed by their labels. And then I run down and connect a bunch of them with edges. There's a subgraph syntax here, but it's all pretty similar, right? Declare your edges and your nodes. So that is a flowchart in Mermaid. This is one that I use almost nonstop in both professional and personal coding. We will. Yeah, if there's a question, go ahead.
Arrange in the right box. What arrange that circle?
Yeah, that's a great question. The question was, what is arranging the? How is the order of the circle laid out? So it's two factors. One is this direction directive, right? If I flip this around and say top down, it's gonna top to bottom. You see it's flipped the orientation. The second one is just it will, like the compiler, I guess, or the visualizer will go through each node and see where, and try to flow down in the direction we're going. So in this case, if we say we're going left to right, it's parsing, like, I'm not quite sure why it's parsing slides as the furthest left, but it's the ordering. So if we break this circle, the cycle here, right, you'll see like draft connects to slide, slide connects to practice, practice connects to reviewers, and so it's it's making that connection, that chain, and then ordering it that way. With cycles, it seems to sometimes arbitrarily pick what's at top, and so I don't know why it comes out exactly that way. But it is trying to order things based on the flow of your flow chart. Great. Okay. So we'll look at another couple. There are another couple that I think are really useful. They kind of build on similar syntax. So we'll look at an entity relation diagram. If anybody's done a lot of work with databases, relational databases, you may have seen these or used them yourself. The syntax is pretty similar, where you can declare, instead of saying flowchart, we'll say ER diagram at the top, and then we declare all the entities, the nodes, and instead of having an ID and a label, in this case we'll have an ID and then a list of properties. And then we can connect them together. The syntax is a little bit different for each of them, but the overall idea is similar, where you'll have your IDs, you'll have an edge between them, and you can have a label at the end. So you can come up with something pretty nicely like this from human readable text here. And then, of course, there's all sorts of the cardinality operators that you would expect for such a diagram. Look at another one or two as time allows, and then we'll jump towards questions. A sequence diagram is another one that is really useful. This is a pretty relatively sparse sequence diagram of what happens when you're looking up a web page. Maybe if that's a little too small, we'll pull out the zoom here. Or you can see you've got a user request something from a browser that'll go and look up the domain name, ask the server, which will pull data from the database, and then back up the stack. So this is pretty useful in systems programming or in user interactions. And again, you'll see the similar syntax. Some of the words are different because you're declaring different types of entities, but you'll see similar where you declare your participants at the top and then connect all your edges together. So that being said, that's a couple of diagrams. There are plenty of different types. I'll jump back over and give you some of my tips and tricks on this, and then we can discuss more from there. If I come back over here, where's my mouse? Great. Okay, so tips are, if you're going to start using this tool, hopefully this kind of talk was helpful for you. If you're going to start using this tool with collaborators who will be needing to review your diagrams or update your diagrams, get out in front of it, send them a little tutorial, take a little time to show them. In my experience, people learning this kind of thing will look at it and go like, wow, that's complicated. I'll just take a picture. I'll draw it on a pen and paper and take a picture and send it to you. But after about 5 minutes of looking at it, they go, oh, this is super easy. Let's use that. You need to check if your editor or your documentation host, depending on what you're using, needs a plugin. So if you're using something like Read the Docs, sometimes you'll have to install some extra plugin to visualize this stuff. The point here in the middle, I think, is important. You should pair your diagrams with descriptions. This is helpful for both different types of learners and also for accessibility. And then if you are software engineering and where you've got some sort of automated pipeline, there are all sorts of tools that automate the generation of this stuff. So I linked one that'll pull from your SeaGL files and generate a diagram, which is pretty great. And then read the docs. They have a ton of different types of diagrams. Each of the syntax is a little different, but the documentation is really good. So here's bibliography. I'll share these slides. You can check out a bunch of these links for yourself. And then I'll put my contact info up here if you want to reach out and ask more questions. But for now, I'll open to any questions in the room or in the chat. Yeah, in the back.
Is there any sort of graceful degradation if you're working on projects? Most people use editors or repository that will render Mermaid, but some people don't use it sort of like exporting.
Yeah, the question was about graceful degradation of mixed environments where some people are using an editor that will render this stuff and some people are not. There are tools that will render this out, this kind of this code out to a JPEG or a PDF or something. So that's an option you could use. Honestly, I've had collaborators who told me they didn't take the time to install whatever plugin to view it, but then still found the diagram code itself helpful, which to me was like, okay, I guess. But yeah, there are options like that. A good option is like if you're hosting documentation, then nobody has to install the stuff. It shows up there if it's hosted on GitHub pages or directly in your GitLab repo or whatever. Yeah, I think there's another question here. Yeah.
Yeah, actually, one statement and one question.
Sure.
Statement. You just mentioned that it renders on GitHub, which is true not just for Markdown, but also for org mode files. So if you're an Emacs user and you use org mode and you use the source blocks in org mode, it renders the Mermaid stuff in there as well. It's pretty cool. Question is, does Mermaid support importing styles and different things like that, similar to how PlantUML does?
Yeah, so there was a statement that said, I earlier mentioned rendering of this in Markdown. Absolutely correct. This can be rendered in several other places and formats. And then there was a question of styling. Yes, it does. Honestly, I haven't done a lot with it, so I don't know if it's going to feel standard from what you're used to. But there are all sorts of, you can change the colors, change the styles, change the... there are multiple rendering images. You can go really deep on how you want this thing to look like.
And PlantUML has some built-in standard libraries you can import in your diagrams. Does Mermaid have something similar?
So the question again for the stream was, are there standard libraries that you can import for stuff? I actually don't know. I haven't. If there are, I haven't had to use them. I haven't come across them in documentation either. So maybe not. Okay. But also maybe yes. Anything in the chat? Any questions online?
I don't see any chat. No.
Great.
Questions. So I think you're good. If there's no other questions, I think we're good.
Any other questions or discussion?
Well, just an insight, I realize you save a lot of time not fussing around with manually creating a diagram. I was thinking it'd take you gotta spend a little time fussing the text, but that's probably gonna be a lot less than for some of us who get carried away with rearranging and fonts and colors.
Yeah, absolutely. Yeah, the statement was you can certainly spend time, really tweaking the code to make it look how you want, but it's less than tweaking images and all of that. My experience is exactly that, especially the second time around. I've got something that's coded up there, and now I've got some great code feature. It's going to change the database layout, and I want to show my contributors, or I've added this extra call. I find myself going back and then looking at the diagram that I drew the first time and going, I should totally rearrange this stuff. Whereas with this, you add your node and it kind of reshuffles things if it needs to for you. I certainly find there's a little ramp up, a little barrier, but then you get a lot of time back, I think, in the long run.
Well, thank you. I think we're done. And
yep, I've got to cede the floor. Thank you, everybody. Hopefully you learned something. I'll see you around. Feel free to find me on socials or find me at the conference. Thanks, y'all.
Thank you.
Thanks for that talk. That's very interesting. I could definitely find use for that. Even for me, as an electrical engineer, I draw state diagrams.
Yeah.
Yeah.
And state diagrams is one of the many supported.
Okay, feel free to start anytime.
Okay. Hello, everyone. My name is Vagrant Cascadian. It's been a while since I've been at SeaGL. Nice to be back. I will be presenting Beyond Trusting FOSS. I've been using free software since the turn of the last millennium, more or less, and also the main project I've been working on the last several years is reproducible builds. And one of the main projects I work in is the Debian project as well. So, you know, we're at SeaGL. Many of you are probably aware, like, free and open source software gives you the various freedoms, right? You're free to use it, to study it, change it or modify it, share it. I mean, this is pretty much like a paraphrase of the free software definition, right? But I think all of these properties also lead to an interesting angle on community, right? Like, all of these properties lend itself to a community. But when you're sharing with a community, what are you sharing exactly, right? So source code might look a little something like this. This is a very tiny piece of the Bash source code, but from a fairly old version of Bash by now, I'm guessing. So that's kind of what source code might look like. It has word-like things. I mean, an average human could almost maybe make sense of this. A well-trained human might actually make more sense of this. In order to transform that into something a computer can actually use, you might run a process like this. So this is the process you use to actually build your software. And then it outputs something like this, which I'm sure there are many people in here who have perfect understanding of what this actually does, right? So basically, the thing the computer actually runs is not very auditable. It's a bunch of gibberish, basically. So one of the main ways we tackle some of this is in the Reproducible Builds project. We are aiming to make sure that when you build a piece of software, and you build it again, and you don't change anything in the source code or any of the tooling you're using, it should come out identical. I mean, exactly the same. Not something that kind of sort of seems to behave the same, but exactly the same, bit for bit identical. And that's really important because you can have something be semantically similar, but it's hard to prove, whereas bit for bit identical is very simple to prove. So how realistic is this? In Debian, the so-called universal operating system, I mean, how universal are we talking? Well, it contains 34,000 source packages and growing, almost by the day. That's 380 million lines of code and growing. And we've managed to make it basically 95% reproducible. So it's pretty much possible to do this sort of thing. What are the kinds of problems that tend to come up when you're trying to make something reproducible? Timestamps are one of the number one problems. If you take a build and you build it, even 1 second later, and it's embedding the timestamp, obviously it's not going to change. It's going to change the result. So as much as you can, try to remove timestamps from the output of any of your projects. And timestamps could also be a date, which is maybe less likely to vary. If you build it an hour later, it might still have the same date. But really, you just want to get rid of timestamps, ideally. Sometimes the username who built it. So if I build it on my computer and you build it on your computer, if the username gets embedded, or the groups, or various other information, what UMask you're running can affect the build, which gets really exciting. Similarly, host system information. You're building on a machine with one host name. You build it on another one. It's not very reasonable to assume that if I want to reproduce the build, I have to build a computer with the same user and the same host name. That's not a very reasonable expectation. And of course, there are just sometimes just total randomness will get embedded in the binary. There are some cases where this makes sense, but usually if you want like a cryptographic hash or cryptographic key, it's better to do that at runtime than at build time, because if you do it at build time and everybody's using the same binary, everybody has the same cryptographic key, and if you know anything about cryptography, that's generally a bad thing. There are tons of other ways. I mean, include a URL to this that links a bunch of other things, but these are some of the easiest ones to kind of explain at a quick glance. But I'll go into a little more depth on time, because timestamps, they're just a perennial problem, innumerable regressions. And so we have kind of what I consider a compromised workaround. So we have the source date epoch environment variable. We've spelled out like how you're supposed to use it and whatnot. It's basically just you set it to the seconds since 1970. It's supported in several major compilers, notably GCC and CLang, or LLVM. I don't remember that whole namespace, but and numerous other ones as well. And basically, what this is instead of taking the current time, if you have a build artifact and you need some time-like representation in your build, we want to take shunt into the source date epoch environment a meaningful timestamp, like say the last commit that you made to the revision control system, or maybe there's a changelog that has a meaningful timestamp in it, because really the time of build is not necessarily all that meaningful, and if you really need the time of build, maybe you should have some sort of publicized build log system, and you can reference that based on the version, and always increment the version rather than relying on some embedded timestamp to tell you where the build comes from. So source date epoch is a way to work around that. So that's one of the things you can use. But you basically also need to provide sufficient information so that somebody can independently verify this build. And that includes the exact versions of the tool chain you're using, ideally exactly where. If you're doing something really right, you might actually want checksums of the packages of the tool chain you did, but at least, like in Debian, that's not very feasible, so but in Debian, a specific version and a specific architecture should generally be enough to get you that information. Source date epoch, you want to record what source date epoch you're using, or have some way of deterministically extracting that from the source. And reproducible builds totally works best with free and open source software. In theory, you could do it with proprietary software with some sort of NDA agreement or something, but really, this works best when arbitrary parties can do the verification, and you really can only do that if you publish all of the source code. So that's one of the most important things. I mean, ideally, you want to be able to have even hostile adversarial parties doing your verification rebuilds. So, you know, say the Russian intelligence agency and the Civil Liberties Union or something are both coming to the same result. That's a pretty strong assurance that you really got the right thing, because they don't probably have a lot in common, right? And you always need to do regression testing, quality assurance. You need to be continually testing your builds to make sure that they're actually coming out reproducible. We have a tool that it's written in Python, and it'll build something and then change some things. It uses a library called FakeTime to kind of emulate the time, which has some bugs. But it'll change various things in the environment that shouldn't affect the build, but actually do. And then it'll display differences between the end result artifacts. And the source code's available on Debian's GitLab instance. And it has a really cool feature where if it's unreproducible, it can bisect the variations. Like it can fiddle with only the timestamp. You know, you build it twice with the exact same set of variations, and then you build it again with with only one variation at a time. So you change like maybe the locale, maybe you change the UMask, maybe you change the build path you built it in, username, whatever. It can do that kind of stuff, so you can at least figure out, whoa, what's the nature of the problem? What is triggering the reproducibility issue? Diffoscope is a tool that ReproTest will call, and it'll actually render, like, earlier when I showed like that binary output from Bash. Obviously, that's not very readable, but Diffoscope has various ways to parse numerous formats and try and render it into something human readable. And it can help locate what kind of string are you looking for, or what got embedded where, what's different, and only show you the differences between these two inscrutable binaries. And when I said binary, it can mean anything. I mean, it could be a PDF, it could be two compressed files, whatever. It'll go through. And this is some example output. It can support like plain text output, or this is, I think, like a snippet from an HTML output. But you'll notice like the version was different between these two builds of whatever the heck it was. And it supports a few file formats, and this is actually grabbed from a really old slide, and really it's as many as can fit, so I haven't added any new ones for years, but the code has added many new ones. So it supports, a few file formats, and always more. And you can also play with it on the World Wide Web. So there's a try.diffscope.org. You can basically hand it two files, and it'll compare them. It's a little less flexible because you have to hand it actual two files, whereas Diffoscope can compare like directory trees and whatnot. But, it's the web. What do you expect? Maybe the WebAssembly folks will come up with something really cool. So what do you get with reproducible builds? You get strong confidence that a given piece of source code can produce a specific binary. So it really creates that missing link in the chain of auditability. Kind of. It's one important tool in this step. So I'm going to get into so this is all about trust, right? So there are all sorts of different levels of trust. You can just run random code off the internet, unencrypted, who knows, maybe you got man in the middle, whatever. That's like one level of trust. Pretty blind trust, basically. You can throw a certificate authority in the middle and, use it on some, supposedly very security-conscious, memory-safe language in order to bootstrap your process. I believe this was taken straight from their site on how to bootstrap your Rust toolchain. Ouch. You can download a file, verify some sort of cryptographic signature, and then run the blind code blindly. Because, I trust these people. You can download source, verify the signature, recompile it from source, etc. My understanding is this is how you rebuild all of Gentoo from source. You could just rewrite everything in assembly, right? I mean, that'll give you a different trust level. You could now we get into the hardware level where you're just rebuilding it up from transistors, manually rebuilding the hardware. Or you have some time on your hands and a leisurely vacation, and you want to build your hardware from scratch, raw materials and whatnot. So those are kind of different levels of trust. Everything's a little, you got to trust something somewhere, right? And this gets into the trusting trust attack. Ken Thompson basically published this in 1984, gave a presentation, and his work was actually referencing work done 10 years earlier. So we're talking about a nearly 50-year-old security vulnerability that fundamentally compromises almost all computing. It's hard to, it is difficult to do, but not impossible, and similar types of attacks on toolchain level. Let me describe a little bit about what the attack is. I mean, basically, his attack basically described how he compiled a compiler with a backdoor, and the backdoor was aware enough of when it's compiling itself that it could inject a malicious code into a new compiler that you build with it, and then you could audit the source code all you want, and this compromised compiler can inject, whatever kind of backdoor in it, and then you keep recompiling the compiler, and you'll never actually find the bug. There were some bugs in it, and there was recently published a really, really cool walkthrough on how it actually worked, which hasn't really been published until recently, as I understand it. So I had fun reading that one. So how do you solve this problem, right? So next level thing, I'm pretty excited about bootstrappable builds. So when you compile your C compiler with a C compiler, and you compile that C compiler with a C compiler, at some point you have to break the chain of just blindly trusting something. And so bootstrappable builds is an attempt to actually get back to the root of trust in something we can actually audit. This is not unique to C programs, right? I mean, the Rust bootstrap, if you want to build Rust 1.73, you need 1.72, yada, yada, yada. Rust 1.54 can be built with mrustc, which was an attempt to actually break that chain, that cycle. And it's written in C++, which maybe has some of its own bootstrapping challenges, but at least we've gotten it down to a simpler set of things we need to depend on. And this kind of thing, bootstrappable builds and reproducible builds together, are basically part of the main proof of concept and somewhat proofed out process for actually countering trusting trust, which is basically if you can build the same exact tool chain using reproducible builds with different original compilers, you can have a much higher confidence that tool chain is not compromised. I'm summarizing a bit and whitewashing it over a bit, but that's the basic premise. You can get into a lot more detail about that. So some folks wrote a little scheme interpreter that was a C compiler used for bootstrapping systems. It's slow, it's painful, but this was an attempt at basically breaking that chain of trust. And another useful thing is this is written recently, so if you got a backdoor injected years and years ago that's just been propagated into all these compilers with GNU+, since it's a recent code base written in Scheme, the chances are people haven't been able to target GNU+, even if they targeted GCC, LLVM, whatever. And we were able to successfully bit-for-bit identically reproduce mess on 3 different distros. It wasn't the best example of diverse double compilation, but because they were all 3 Linux distributions and they were all using GCC, but there were 3 different versions of GCC at the very least, and 3 different distros with a slightly different history. Probably at some point, lost to history, you could trace them back to the very same compiler, but at this time, so we did the first real-world example of diverse double compilation because this is actually used in GNU Geeks to bootstrap. And then GNU Geeks took it another step further. So, this is the reduced seed bootstrap. So basically, originally to build Geeks, you needed a boatload of binaries. Guile, I believe there was a GCC in the mess, a bunch of other things, and it was about 250 megabytes of binaries. So that's 250 megabytes of gibberish you have to go through and audit. Not really practical. They reduced it down to 145 megabytes, which is still not really practical. But by using mess and guile, they knocked out 100 megabytes on an auditability chain. And you build from source, you get to GCC, binutils, glibc, and then pretty much from there you can bootstrap almost everything else. But that wasn't enough, because obviously, 145 megabytes is not great. So they did a full source bootstrap, which is rooted pretty much in a 357 byte binary. it's a tiny little bit of well-commented assembly hex assembly code, and this is used to bootstrap a slightly more complicated compiler and another one, etc. So we're just bootstrapping a bigger and bigger, more complicated, more sophisticated base of tools up until you get all the way up to what a fairly capable C compiler, and then you bootstrap the rest of the world from that. There is a dirty, dark secret to this, and that there's still a binary blob of guile used to kind of orchestrate the whole process. But I believe there are people scheming about how to solve that problem. But yeah, you basically get to a modern GCC by going through some old versions, etc. There's also another project using the same path to bootstrap a live environment, where you start with a kernel, some source code, and then you get to a reproducibly bootstrapped toolchain. So that's pretty awesome. Again, you're yanking out some things, and they avoided some shortcuts, like removing some auto-generated, like automake stuff. They're really going targeting true source code. But, that still needs an operating system. So what are you going to do? Obviously, you could compromise it like in the kernel or something, right? Well, there are folks working on this whole bootstrapping process from a UFI binary, right? Then there's also a bare metal bootstrap going on. So what I really want to stress is, there's the whole trust but verify thing. But really, forget trust. Let's just verify, right? Let's just go straight for it. And in order to do that, in order to do it properly, you need free and open source software so that you can have completely independent third-party verification. Reproducible builds gives you the strength of confidence that the source code you're using is actually producing the binaries you're running. And bootstrappable builds helps protect you from trusting trust attacks, and all three of these together are much stronger because they're all needed in order to properly do diverse compilation. Building with a variety of different compilers, getting a bootstrappable result that you can then use to springboard off into the rest of the world. And you need a lot of compile cycles to get this stuff all to work. But really, I mean, trust is a good thing, and we're building a community, but I don't want to share compromised binaries with people. I mean, that doesn't feel like a good kind of sharing. I love the sharing spirit of free software, but it doesn't feel quite free if you don't have confidence in what you're sharing, right? So fundamentally, these various projects are all interrelated, and they're all stronger when you have all three. Each one is kind of cool in its own right, but put them all together, we have some beautiful. We're looking at solving 40, 50-year-old security problems. I mean, who can complain about that? So thanks to all sorts of people who have contributed to various projects. I'm mostly focusing on reproducible builds because that's where I'm housed, but I also putter around with some of these other projects mentioned. We could really use some funding, so if you have any ideas about where to get some funding for reproducible builds, please get in touch with us. We already are sponsored by Open Technology Fund, Civil Infrastructure Platform, Melvad APM, and I think Protocol Labs still. And here's the fine print on licensed under Creative Commons, blah blah blah. Some stuff is Free Software Foundation, yada yada. Anyway, what do y'all think? Any thoughts, questions, criticisms, dreams?
I've got a question. You're talking about. First of all, this is super interesting. So thank you for the talk. You're talking about the diverse double builds, and as a way to have two actors on the opposite end of some spectrum agreeing on the build, and that says something. And I guess along with the rest of this, how do we scale this up to you're talking about Debian and something that's core to so much. how do I scale this to my project or whatever little
Right.
random software I'm going to pull from
Yeah.
the repository?
Well, you can just first try to make sure that your software project's reproducible, and then any projects you use in order to build your software, like you did a talk on the Mermaid project or the Mermaid documentation format, what's in the entire dependency tree of that. See if there are anything in there that you know how to work with, and possibly make it reproducible, see what the bootstrap path is for it, that kind of thing. So, basically just, and the great thing about this stuff is you can attack it at many different layers. Every layer helps. We need it all in the end. So whatever layer you're confident with, start with that. Yeah. Are we done?
I mean, we still have a few more minutes for questions.
All right. Any other thoughts? Oh yeah, like as far as targeting it at any point in the chain, I mean the bootstrappable stuff is really good for this. People didn't start from here, right? People started working on this thing, and then they worked on this thing, and then somebody did that one, and somebody did that one. I mean, I'm not exactly in the correct order, but at every point, somebody can work on whatever scratches their itch. Maybe Scheme is your thing, so that's why they started on Mess. Maybe you love writing in assembly, whatever. You can attack these problems from wherever your skill set and comfort level or interest, if you just want to learn. Yeah.
This is about bootstrappable builds, but a lot of bootstrapping problems come because language developers or implementers like to have a self-hosting compiler.
Yeah.
And so therefore, pretty much any new language is introduced, we have a bootstrapping problem. A lot of these have been solved, as you mentioned, Rust has been dealt with and stuff. I don't keep up too much with where the state of things, and I'm curious, are there any language ecosystems out there that are particularly pernicious or high priority to fix? I feel like Java, there was some progress on bootstrapping Java.
Java has a reasonable story, I think. I don't know in great detail.
Yeah, I'm just curious if there's any
the main outliers, I think, are Haskell, if I recall correctly, and I mostly know it from. I also work on GNU Geeks a little bit. I don't know if somebody else can even answer that. What are the main outliers?
I just
still?
haven't kept up with it. So
Yeah.
I think Kotlin's a good example.
Kotlin, yeah.
Especially because it's used so much in
Right.
Kind of a high priority language.
Right. Yeah. I mean, and then there are some issues with GCC and LLVM, profile guided optimization is a real thorn in the side because it theoretically could be done reproducibly, but it's not right now. And so GCC itself is not necessarily reproducible depending on how you build it, but the optimization gains from profile guided optimization are pretty hard to fight. Although with my reproducible builds hat on, I would rather have the confidence in a little less performance. Maybe you can have a GCC profile guided optimization version of the compiler if you really need those speed gains. But yeah.
Okay, well, I think that's it.
All right.
Thank you very much.
Thanks, everyone.
think it should work. No, this is the capture.
No.
Whatever. No, yeah, this.
We're just playing the video. I don't think we're using OBS.
Yeah.
Noichimai, right?
Yeah.
Okay, I'm gonna go grab UW.
Okay. I think Romeo's already doing that.
No, he's not.
Oh, okay.
I'm gonna do it for him.
Okay. Hello.
Yeah, this happened earlier.
Yeah, they used the duct tape solution, I heard.
Which was just streaming it over wireless.
Oh. I thought it involved actual duct tape, and I thought that's funny.
Oh no, it's 337, right?
For those who walked in, we're just trying to get the projector working.
That's why we're here.
I feel like we need another laptop.
I mean, it's useful for doing stuff where you have to get up to most of it.
Hey, I gotta go deal with another crisis. There's a UW person coming to look at the HDMI here.
Okay.
Okay.
It's kind of ironic the talk is programming an OS distribution when we can't get the projector to work.
Minor detail.
Yeah.
The low-level stuff is fine. It's the high-level stuff that's all mysterious.
Interrupt me as soon as it's necessary. There's people in who haven't listened to me. Oh, well, haven't had the opportunity.
He was having to do with
Plastic bags hold everything. And if you carefully open the plastic bag, and by the time I get done talking to you, you will learn to do that. If you fold it in an appropriate amount,
Plastic mirrors out.
it becomes a
Oh, there's one
whole.
right here. Never mind.
The content is right there. And when you eat it down, You just take a minute and
Is this your
fold it
laptop?
down.
Yeah.
Okay.
I'm not
Another-
using it for that because I don't have anything set up.
And you keep folding it down, 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 and you get to the bottom and say, well, that was fine. Then it keeps you from reaching to the bottom of the bag and getting the back of your hand all covered with the oil from the contents. So much.
Alright.
And I had a capture
Yeah,
box.
so we're not able to get anything displayed onto the projector with this HDMI cord.
Mhm.
It was working somewhat earlier.
Do we have we had anything show up on the projector?
No.
Give me 1 second.
Okay.
Do you mind unplugging everything for me really quick?
Yeah.
What's this USB? Oh, that's room audio, isn't it? Oh, we have this now.
No. No, I did that.
Okay. I'm grabbing another laptop.
Hey, and then you can plug it in now.
What else do we have? Can we get HDMI out of this?
You think it's that?
No, this thing is not.
Wait.
Wait.
Just rebooted it.
Okay, so this thing sees the projector. Extend to left. But the projector doesn't see the video. I used my laptop in here a minute ago, and it was the same story. The projector, I can see the projector, but the projector is not showing anything.
Is it the cable?
Do we have a spare cable?
I don't have a spare cable.
We
on
have
me.
a spare cable somewhere.
On me, I can go get one if you guys don't have one.
Yeah. Is it possible to unlock this so that we can?
Hello and welcome everyone on SeaGL 2023. I'm Andrew Tropin, I work on operating systems and programming languages and do a lot of free and open source software development along the way. Today we will discuss how to use only one programming language to create and maintain the whole operating system distribution. And the obvious question is why we would like to do it. Nowadays, in most cases, at least for power users and probably for people who are attending this conference, using an operating system is almost equal to developing of operating system. When you change a line in the configuration file, you update the source code of your operating system. If you install a package, you implicitly, in worst case, modify the dependencies of all programs, edit the source code, edit the headers and other stuff at the same time. By the way, do any of you track the whole root directory in version control system? Probably no. And because of it, you don't actually know what happens with your system when you perform some commands. For example,
off the stage.
Oh, that is not the video that we want. That needs to go like that. That needs to go like that. Hey, that just works on the first try. Love it. Okay, but we need this to come out of there and to go into here.
Is there a camera in this room for pose?
For what?
For pose.
For pose?
Post.
Post.
Like the other room.
Yeah, no, we don't have that for here. I mean, we could, but it would get overlaid. All right, is that going up on there? Is this visible? On the projector? Uh-oh.
Not quite.
Do you want me to kill that? That's live.
That's fine. There's nothing embarrassing on it. I just gave it the wrong setting, though.
Okay, but that's not up there. Oh, it wasn't plugged in all the way.
Mirror, yes. Okay.
Hey there, it's up there. Wonderful. And it's here as well. Huh? Do I need you to what?
Do you need this move? Or are you good?
I don't know what I would need about that.
Just it's plugged in. I just didn't know if you were walking back.
Great, you are you're live and recording, and there. That is the only thing.
I wish I was doing like a motivational seminar where I put the headset on and was like, "You gotta be you. You can't be anybody." But sadly, no. I'm just gonna stand here.
You're live. You're ready to go.
Okay, but thank you. Not that. Just do that. All right. Okay. All right. Oh, she's got her mask off. It's a moment. Can everyone hear me okay?
Yep.
Good. Awesome. Sort of doubt I wouldn't be heard in this room, microphone or not, but we do what we can. Okay, so this is an adaptation of a previous talk which went into a little bit more depth about some of the details of OpenTelemetry. So let me start by asking where we're coming from. Who here is using OpenTelemetry now to monitor a system? Cool. So there's introductory material at the start, so that's good.
Ron just sends me a weekly update of my syslogs.
I'm sorry?
Ron just sends me a weekly update from my syslogs. I'm ancient.
So, I will say, if you ever feel like you're not sufficiently sophisticated, in this observability space, and that's a really good one, people are like, oh God, I hate to admit it, but I'm just setting logs, and it's just you out there walking up the temple steps with a bucket of water, and everybody else is doing something very sophisticated. Penetration of any observability tool other than remote logging is 50% in the industry, right? So don't worry. New Relic, Datadog, every single observability tool out there, 50% market penetration. Everybody else is just grepping the logs when they have a question. It's just tailing logs. It's just looking at whatever stats, whatever other more straightforward Unix level tool. So don't get too stressed about that. Do put your phone on Do Not Disturb if you're out to give a talk, because there's going to be a push notification up there that's deeply weird. But, so this is filtering the noise. So, a common question, especially among new DevOps engineers or SREs who want to add observability, is what's the first thing that I should instrument with OpenTelemetry? My answer there would be, whoa there, sport. What do you think OpenTelemetry is? Which is a really good place to start. Ooh. I'm not doing it the best. She's too hot, folks. She's too hot, folks. Like this one, I stitched this one myself. I'm rather proud of it. Anyway, so what is OpenTelemetry? It's a big project with multiple components, and this is a really good place to start because you have these conversations like Datadog is too expensive, I only use OpenTelemetry. What do we mean, right? What is the component that we're talking about? So, sorry the text's a little small in that version, so I don't think I'm going to go with the presenter's code where you read every piece of text on screen. We'll see how we do. So what is and isn't included in the OpenTelemetry project? So it consists of a specification for all components. That's quite critical. That's the part we debate all the time, and you can't just do casual commits to change the spec. A standard protocol that defines the shape of telemetry data, or the OpenTelemetry something protocol, OTP. And then semantic conventions that define standard naming scheme for common telemetry data types.
And boy, doesn't that sound just so arcane? Folks, I've worked with observability tools for 10 years. That is the most important thing that OpenTelemetry has ever done. So count, like metric.sum, that always means the same thing, is such a big deal. It's such a big deal in terms of what that standardization means. APIs to define how to generate telemetry data. A library ecosystem that instruments instrumentation for common libraries and frameworks. Now we're starting to get to the meat, the hard development work of OpenTelemetry is going through and defining. We're going to create libraries to gather data, and a lot of us think of, especially if we compared it to closed source observability tools, it's like, well, OpenTelemetry is like you're doing everything manually. You're going through and sending metrics or sending values manually. Not at all. Like, the library ecosystem is quite good. And so in a number of languages, you can just install this package, start getting useful data right back from your production environment. Language SDKs that implement that specification, APIs, and export telemetry data. I am going to read every word of this. So good. The OpenTelemetry collector. Now, the collector's a really cool piece. The collector, that name trips a few people up because they think of it as, oh, well, that's the thing all the way at the back that's collecting all of the data. It's called the collector. That's obvious. I think this is public knowledge that New Relic, like the thing all the way in the back, the database, everything is called the collector. So that's it. No, it's kind of a middleman. It's grabbing data directly from your code and sending it on somewhere. And so it is not necessarily, or it does not imply the data store format that you're going to save it in, nor is it anything that's going to like populate your dashboards with that other stuff. So the collector is a middle point. I think actually it turns out that the collector is really standardized to sort of mean that, and that was just a misunderstanding in my time at New Relic. But anyway, by the way, I'm not at New Relic anymore. I'm with the open source observability company SeaGL, that plugs into this ecosystem that does none of the things here. All of this is covered by OpenTelemetry, and we do this other piece. So then there's other tools like the OpenTelemetry operator for Kubernetes, the OP-AMP project, which is about letting you modify the collector without having to restart the collector, other cool little pieces. So what's excluded from here, and it was implied in some of the stuff I mentioned before, is any kind of data storage, database, dashboarding tools. So all of that stuff is left up to the reader. And so that matters because there's a couple things. I think strategically it means that the OpenTelemetry project is not in direct competition with your Datadogs, your New Relics, your other big observability players. It also means that you can get kind of far at this and discover, okay, where do I see my data? And it's like, no, you got to go use something else. So for open source tools, that would be Signos or Prometheus in general. To view that stuff, Prometheus more for like viewing pure metrics, maybe Loki to view traces, and then there's a bunch of closed source tools as well where you can send your data from an OpenTelemetry install. Okay, the first thing to look at with OpenTelemetry is infrastructure metrics. After all, it's totally free, right? You can go ahead and grab this data. You're not adding any execution time to your code. You're not having to modify your application setup at all. You can go ahead and grab that infrastructure data. We all know what we're talking about there. So after that, we're starting to talk about automated instrumentation. So this is from a great, I have the link embedded there in tiny text, but I'll also share it as part of the stack. This is the concept of a Java agent. So in Java is where this is the most applicable, that a Java agent is part of a pre-designed part of the spec that says, hey, go ahead and allow yourself to do bytecode manipulation to add in new calls for instrumentation. So completely part of the spec, super clean. It's one of the reasons that Java produces the best OpenTelemetry data is because it's part of the spec. It's not something that requires hacking of any kind. But the idea is that automatic instrumentation is the first place you want to do for monitoring our application code. We don't want to be going into the application and making small modifications to get things working, which makes sense because in general, especially as we get to a larger org, it's not good. This is going to come up again later in this presentation. It's not good if we have this nice dashboard of all this observability data, and we see, oh, this isn't quite right. This trace or this information or this metric isn't quite right. And then what you have to do is like a GitHub commit to your application code to fix that. When you're a team of 3, that is fine, right? That's no big deal. But once you have to go down to the product team and say, hey guys, I messed up tracing again, and this thing's not getting the right labels. So can you stop whatever work you're doing to deliver features and modify this for me so it reports right? Not great. So it's really nice in automatic instrumentation that we didn't have to ask them to do any of that. We didn't have to ask them to kick off traces, to start making modifications, to send observability data. We were just able to say, hey, we're going to go ahead and add this requirement, maybe add something at the very initialization of the app to add this stuff, and then we're done. How that's done in different languages varies significantly, but done in all major languages, so doable in all major languages. Only in Go is it a little bit of a thereby hangs a tail. So then you need to send your data somewhere. So the collector consists of 4 components that access telemetry data, which is our receivers, our processors, our exporters, and our connectors. So again, what's outside of the collector: data storage, visualization and dashboards, retention policies on data, and alerts. All that you're going to cover with tooling that's outside of the OpenTelemetry project. And that's, that's about competition. That's not necessarily a terribly logical division of responsibilities, but that is the way it is. So I don't think I have a slip about this. We'll talk more about like what's inside the collector and what it can do, time permitting. So once you're collecting those hosted infrastructure metrics, once you're thinking about application metrics, a good next step, I say second step in here because I changed the order of slides, but next step, because it's actually a third step, is thinking about logging. And so then you go and look on the OpenTelemetry site, you say, okay, what's the state of logging for my language? And you're like, and you see like, no, it doesn't work. And you're like, oh no, it doesn't work. So really important distinction here. You can have the OpenTelemetry collector pick up on your logs as you're sending them now. No problem. That works. That's just part of an OpenTelemetry receiver, right? This first component here of the OpenTelemetry collector. So you just have a receiver go ahead and pick up the logging that you're sending now, because I guarantee you are sending logs somewhere. Well, maybe you're not, in which case I'm so sorry. But if you're sending them anywhere, you should be able to send them to OpenTelemetry. So this is just about whether or not that language SDK can get a call to that SDK to say send a log line as follows. And the reason that this is the least stable part or the least baked part of OpenTelemetry is because you are already sending logs somewhere. And so it's not the most high priority thing to get implemented in every language SDK. It will be there, but there's some issues with standards evolution. This is like a great question for Austin Parker, who's on the board, to talk about more. And we'll hear more about it at KubeCon next week. But yeah, so don't get too discouraged by this, is my point, because you're probably already sending logs somewhere, and so you can do it. Depending on language, like you can do them from, like with an SDK called as well if you want. Right, you're probably sending logs somewhere. So you can go and take a look at the receivers in the OpenTelemetry collector contrib repository, and this is an important, like, write this URL down. I mean, don't write, but you know what I'm saying. Like half of the questions that we get about OpenTelemetry are like, oh, can you get this kind of data? And they usually come in kind of a funny way. They're like, people will join the SIGNAS community Slack and say, hey, can SIGNAS accept data from this kind of data emitter? And it's like, well, we just take OpenTelemetry data, so probably. Just go look here. Is there a receiver for that kind of data? Then yes. Right? Because once it's in the collector, it's going to get transmitted in the standard OpenTelemetry format and can just be transmitted to the backend. I have no idea where we are on time. Somebody here's our time person. Time clock master.
You have another 17 minutes.
I have another
17 minutes.
Rad.
And
how is that?
I have warning signs.
That's so great.
Too.
I haven't just talked for 3 minutes. I know that's not real, but it's all right. I'll figure it out. Okay, so let's talk about logging, and let's talk about the way that OpenTelemetry is still like the incomplete pyramid. I don't know if you guys are big Jay-Z fans, so you want to talk about like Illuminati stuff and incomplete pyramids, but this is an example thereof, where the vision for OpenTelemetry as time moves forward. So the great thing that OpenTelemetry is doing now is standardizing the way that metric data is sent, creating open source libraries and agents to monitor your application code. These are all great things that the project is doing. But there is a kind of perfect future that is maybe coming someday, which perfectly braids the signals of telemetry together. So that says you're running these things called traces, which are saying, hey, this method was called, then this method was called within that, this method was called synchronously, this one was called asynchronously. You get the nice trace like we're all used to seeing from a debugger view in a million different ways. It would be nice if every log had a trace. And it would be nice if every metric was also connected to a particular trace. And it would be nice if logs and metrics could be like intimately connected. So that is not happening yet. So logging, if you're doing logging by plugging into your current logging pipeline, then you're not going to have any clue what trace was running at the same time that log was emitted. And we're going to talk a little bit about ways to tie them together a little bit. There's ways to transform and tie them together a little bit. But, until you're using the same SDK to send your traces, your metrics, and your logs, that's like step 1A to having these things be connected. Also, at a more fundamental level, some of the metrics you send are going to be things like, hey, this was the response time of this method. So you can see how that's pretty intimately connected with trace. And logs submitted at that same time with a similar ID, like a similar request ID, should be connected. But other metrics are going to be things like, hey, we sold this many shoes. And we just incremented that number by 1 because this whole request was a shoe sale. So how is that connected to like a particular trace? Like it sort of is, right? It might be that this metric was emitted during a particular trace. What if the metric being emitted is we sold another pair of shoes with this trace, so the total number of shoes we sold is 20,001. Well, now the connection to a single trace starts to sound kind of weird. And this is just going to be true of a lot of the metrics that you emit, right? A lot of the metrics you emit aren't necessarily going to be in the same way intimately connected. And in fact, this is why some tools to show you OpenTelemetry data only show you one of the 3 types. Because they're like, look, it really doesn't necessarily make sense to tie these together super tightly. So like Prometheus's big focus is on just showing you metrics, because metrics probably are telling you something very different than what you might be looking at with traces. And yeah, use your regular logging tool, don't use a new logging tool. That's sort of the Prometheus ethos. So someday, these will all be intimately correlated. This is from the site and says what I just said. But I'm not going to read it, so I've now broken the pact. So now we get into the day-to-day stuff. Once you all move from where you are now to being big adopters of OpenTelemetry, this next part is something that kind of comes up as you reach like a medium scale. And was this thing I was talking about where you say, hey, I don't want to have my application developers have to modify their code to emit good observability data. We would really like, since they're not necessarily terribly concerned about what that data is or where it goes, it doesn't really make sense to have them be the ones who are responsible for modifying it. So OpenTelemetry instrumentation, like any code level instrumentation, sends lots of data rather easily. Some of that data is noisy, some of it is sensitive, some of it is good but needs tweaking. When faced with the data collection problem, it would ideal if we could solve it without having to commit any code changes. And I think that's making some sense, right? It's like, hey, that's not an ideal situation. Let's sort of belabor that point. So, take a look at this code. I used to have this ancient, totally fantastic, like geoinformatics prof who would absolutely do that thing of like slapping something down like this on the overhead projector and be like, as you can see, moving on. And you were just like, and it would be like the worst photocopy in the world, be like a 10th generation photocopy. It'd be like, the data clearly shows be like one little squiggly. You're like, I don't see anything from that. But in this example, I'm emitting some data right here. I'm setting some attributes on my trace that are saying, hey, here's what's going on with this particular span of time within that trace. I'm going to say this is the user that's emitting that span. What do I say also? Here's their database key. Here's some other information about what's going on with them in this trace. And these are calls that I had to insert as a developer because I knew they were super important and I wanted to emit them to my OpenTelemetry backend. So now I become someone else. I become one of the operations engineers or one of the SREs who's looking at this and saying, we really don't want to have the user database key just appearing in plain in our dashboards. That's like not great. It's not terrible. It's not like, oh my gosh. And that's sort of the problem. If it were terrible, maybe I could go to the product team and say, hey, could you take this out? But if it is, it's like, no, I need to obfuscate this a little bit, but I really don't want to have to go back and modify this application code. So let's talk about where the collector sits in our arrangement. Boy, I wish I had this diagram a little earlier, but that's fine. In this case, we have multiple OpenTelemetry collectors running within our map. And so this is a fairly common setup where you have collectors running very close to some services so that their latency is very low, and they can be dedicated to certain areas. But then they report up to some big collector, which then reports back to our data store. And maybe like all of this stuff at the left, everything off of data store is reported in one place. Maybe this guy is happening someplace else. It doesn't really matter. But this architecture, which is relatively simple to implement, means that if we can get to one of these collectors and start modifying how it transmits data, we can start making really smart choices about the OpenTelemetry data that we send. So if we can say, hey, from these edge services, I really don't want to omit anything about geo data because it's too specific, it's too traceable, I don't like that. You could just modify this OpenTelemetry collector A and leave me generating whatever data it does. If it's something like the database key, man, I never want that to show up in any dashboard. You can start to say, oh, well, let me go ahead and modify this collector here that gathers all data before it goes to the data store. And you can, sure enough, configure that such that data doesn't send. This gets into sort of what can happen inside of an OpenTelemetry collector. I'm not going to dive too far into these implementation details. Go try OpenTelemetry out. Go try it out on your application. Report some data to your console. Report some data to like a self-hosted instance of Prometheus or Loki or Signos, and try that out. Don't get too stuck on this filtering stuff. This is a possibility that you have, is to say, hey, I only want to send certain data. You can go ahead and say, hey, if I see this attribute, I want to dump that data, and it'll disappear from your dashboard. You can say, hey, I will set a bunch of filter conditions, which will dump certain stuff and keep other stuff. And there's pipelining of these filters, which that's a part that's really nice. You can say, hey, go through it, scrub it for this, then batch it, then compress it, then send it, etc. Well, batching you want to do less, but this is the idea, is that you can make some smart choices about how you're going to apply these kinds of filters. And you can use regex to do that processing. Again, if you've dived into this already, this is like nice to know because it doesn't quite work the way you would expect. And regex has some limitations, which we're not going to cover because we're not quite there yet. And you can go ahead and transform stuff. So if you want to say, hey, I have these two data points and I want to kind of smush them together and have them be a single attribute, you can do that. In this case, my transformation is saying, hey, don't show the full database key. I want the last part after the underscore, but I don't want the full database key. So it replaces it with, hey, just replacement ID, and then the string at the end of it. Last thing to maybe think about as you're sort of planning your big journey into OpenTelemetry is that there are some limitations to what the collector can do. So, like, what can't you do? Quite a bit. So, the big one there is that when we have a trace is a series of time spans that are stitched together to say, hey, handling request, hit all of these time spans. And naturally, in a microservice world, it's a little bit of a trick to get those to stick together, to say, hey, we're going to propagate this context across our stack and say that all of these time spans are part of the same trace. OpenTelemetry tooling and the SDKs do an extremely good job of this. I can do a lot. But when they break or didn't work at all because you didn't implement that tracing on a certain part, once you're looking at stuff in the collector, you're not able to do that stitching like you might think you could do. So if you have some time span reported, and it has the same user ID as the span you were looking at a second ago, you can't go just say, hey, that span is part of this other trace. Go ahead and stitch them together. You can even go and set its trace ID so that, oh, cool, now they'll match and show up together. Won't work. So there's some reasons for that. The act of restitching your trace is quite computationally expensive, and so there's some reasons why that is that way. But just keep in mind that you want to implement a full instrumentation solution don't worry about this. You'll get to this later. You want to instrument a full open telemetry solution before you dip into saying, oh, don't worry, I'll stitch it all back together at the collector side. Be cautious. That's the end of my slideshow. I'm Noshnika. I'm from Signaz. If you have questions, come look me up on Twitter or Blue Sky or nowhere else. Thank you, everybody.
What exactly is Blue Sky?
Blue Sky is a private or non-shared Mastodon instance run by one of the former Twitter assholes.
It's Jack
StreamYard?
Twitter to Elon Musk.
Huh? StreamYard scene?
Is it Jack Dorsey?
is malicious code. So another benefit of assembly continually helps to improve and expand this capability. So it's actively being worked on. So you can say it's not like a technology that is just built and is there, it's not maintained. WebAssembly is actually built, maintained by the open source community, and new features, new um, technologies, new updates are being added to it. So there is a future proofing for WebAssembly, continuous maintenance, and continuous support for WebAssembly. So native like experience. So WebAssembly like enables development of web application with like native like experience, like I said earlier. So it blurs the line between web and desktop application. You just have that feeling of you are running in it a native like application but on the web, right? Another benefit is interoperability. So WebAssembly allows interoperability, meaning you can write code in a particular language and execute it on the web. So it doesn't have to be like a web language. It can be any language that compiles to WebAssembly, right? And basically, all the languages compile to WebAssembly, like most of the popular languages compile to WebAssembly. So yeah, that interoperability where you can write your code in C++ or C and compile it to WebAssembly. You can write your code in Rust, compile it to WebAssembly, and it runs on the browser. You don't have to go through the learning curve of learning the browser's language and all that, right? WebAssembly also like seamlessly interact with JavaScript, right? And JavaScript libraries, JavaScript framework. So it allows developers to, you know, seamlessly build um, application that interact with JavaScript, which is the language of the web as well. For open standard, another benefit of WebAssembly is that it's an open standard application, right? Developed by the Worldwide Web Consortium, that's the W3C, making it accessible to all developers and ensuring that it remains like a and free from proprietary restrictions. So it's a free software, it's an open source software. You can actually take it, modify it, make it better, build on top of it and all that. That's like another benefit. And then browser integration. So WebAssembly basically work with almost all the browsers, right? So it integrates with basically all the browsers. And another maybe popular benefits of WebAssembly is it compiles coding to like a little size, like it reduces the size of the code like it reduces the size of the compilation compiled code. So because the compilation targets right for languages to compile to assembly module and run on the browser. So when it compiles, actually reduce the heavy size from the languages they are coming from. When they compile to WebAssembly module, you reduce the size so that something that can seamlessly run on the browser. So far, and many other benefits of WebAssembly, but these are like the key ones that we're looking at in this talk. So we're looking at the use cases. So we've talked about the use cases before, but we want to look at it based on maybe industries and different computational methods, right? So let's look at web development basically. So WebAssembly, you can create like rich interactive visualization and multimedia experience on the web. You see the HTML5, Canvas, and other multimedia, right? So it opens like a whole world of possibility where you can build high quality and rich interactive visualization on the web and multimedia experiences as well, and progressive web application. So you can make your application to work offline, right, and load quickly and provide like app-like experience as if you are connected to the internet. Well, you are not connected because you've compiled most of the module, right, using WebAssembly and save everything for offline use. So this is like the situation for progressive web applications. and make it faster, more efficient using WebAssembly. Then for desktop and mobile, WebAssembly can be used to run compute-intensive tasks efficiently, enabling the desktop-like performance in the browser. So you can use WebAssembly to run high performance computing tasks, right? Tasks that are that requires like more computational power. You can run them on the browser or desktop and mobile application by the virtue of WebAssembly. So, right, a typical example of this one is like some of the blockchain, maybe running a blockchain, or something that involves like running a blockchain node or something on your desktop. So if the application is allowed to compile to WebAssembly, right, it can make it like seamless. You don't need to maybe experience performance issue and all that, right? Because it compiles to WebAssembly first and then gives you that performance uh, beautiful experience. Yeah. So then the native like user experience. So using WebAssembly, developers can build web application that mimics the user experience of native or desktop mobile apps. So using WebAssembly, developer can build web applications that behave totally like desktop or mobile apps, right? So that's like a typical use case. So another one is in gaming and in multimedia. So you can see in for example in Unity Unreal Engine there is this feature where you can compile to WebAssembly so that your games can run on the browser, right? So you also like get like real-time graphics and audio. Like I said, nothing needs to lag, right? Because you are doing the heavy lifting, the high computational stuff, and compiling it to WebAssembly. You are not running the high computational stuff on your browser. You are just running the compiled code from WebAssembly module on your browser. So WebAssembly does the compilation, the heavy lifting for you, and then you run the binary code on your browser. So making game development on the web very awesome. So also like seamless deployment across platforms. So with WebAssembly, game developers can write their code once and have it run on different platforms without having to worry about it, right? About another use case which is in scientific computing and data analysis. So you can also use WebAssembly to you know speed up complex calculations, right, and scientific simulations. So you can think of one scientific simulations or calculation, something like a zero knowledge proofs, ZK proofs, right? So ZK proofs is takes like high computational power because it's basically running some scientific simulation, let's say mathematical computation, like in the background, right? So using WebAssembly, if it's something like maybe you want to run a ZK app on the browser, so want of course users to like have a feel of that ZK zero knowledge proof on the browser. Maybe you want to use it in a particular application, but then we are worried about this thing takes a lot of computational power. It might not run on the browser. They might experience glitch or performance issue. So we can actually use WebAssembly to do the heavy computation, right? And then use the compiled binary on the browser, and everything works seamlessly. So researchers, scientists can and data analysts can use WebAssembly to do the heavy calculations and scientific simulations as well, right? So also in edge and cloud computing, WebAssembly helps you to offload heavy intensive computational tasks to remote servers. So you can use WebAssembly to that's what they call it. That's what they call it. I'm trying to remember the name, but if I remember, I will say. So you can use it to offload computational intensive tasks to remote servers, right? Can when maybe when a particular server is experiencing high surge, from usage, you can use WebAssembly to offload some of those tasks, right, to other remote servers as well, enabling your application to handle the heavy workload without putting too much strains on the user device. So you don't have to like rely much on the user's device for some of the computational tasks, right? So you do everything for them on your remote servers and serve them the data or the feeds they need to work on their applications. So I remember the word load balancing. Yeah, that's what I was looking for. All right, another use cases of WebAssembly, another set of use cases for WebAssembly, is in embedded system and IoT devices, right? So WebAssembly small size, when you compare your code from the target programming language, right, to WebAssembly module. So, like I said, it helps reduces the size of the bond of the code, reduces the size. So, this size reduction capability make it efficient for WebAssembly to be used in embedded system or IoT device, because most of those devices doesn't have large memories, right, or large random access memories, to random access memory to perform some of these big computational and computation task and all that. So when you compare with WebAssembly and then serve it to these devices, so it makes it like efficient and suitable. So you can use WebAssembly to compile on all these resource constrained devices like microcontrollers, allowing for development of IoT solutions. Also, you can use WebAssembly to write code that runs directly on the firmware. Like I showed in the architecture, it runs across different OS, different operating systems, right? So you can use WebAssembly and write directly on the firmware of the IoT device on the operating system, and it will work fine, right? So for blockchain and decentralized applications, so WebAssembly is currently used to build smart contracts to enable decentralized computing in blockchain networks, enhancing security, trust, and transparency, right? So that's like the goal of decentralization, security, trust, and transparency. So with WebAssembly, you can write secure smart contracts and all that in the blockchain space. So it's also like the sandbox environment provide additional security layer for running decentralized application, making them like less prone to attack. So a smart contract within WebAssembly is less prone to attacks than the one written in maybe probably Solidity directly, or the one written maybe with C plus Rust then compiled to WebAssembly, is less prone to attacks, or even Solidity compiled to WebAssembly.
If you don't mind, I would like us to validate the audio before we start, because I definitely know there are going to be folks watching.
Yeah. The mic's already going for this. Cool.
Okay.
Okay, and then.
And I can take my mask off while I'm presenting, right?
Yeah.
Okay. Making sure. I know everyone was not doing that.
I think it's having the laptop issue. Okay.
Well, I gotta tell it too, I think. If you'll let me set it down, I can from my side. I generally do not have mine be friendly to things that get plugged into it by default.
Yeah. Oh, okay. That could be the problem then.
Well, it's probably expanding to nothing. What resolution?
Any. Just set it to mirror.
I can't do that.
Oh, okay, then 1080p then.
I can't do that.
Are you on Budgie? What desktop? Oh, that's Gnome. Never mind.
I don't know why you got nothing though. This is sending you 1080p at 60. Do you need me to lower to 30? Let's try 30. 30's not showing up, it seems.
I might need to try the cheese workaround. Alright. It's showing up on OBS now. Is it? I might have to call in Romeo because it's not now. It's showing on here, but not on there. So I need to figure out why. It should be. Is there an input switch? Because
I have no idea about any of that, but this is. I can do the. It's not my Linux's fault dance at this point, at least. Hopefully. All right. Let's see. I don't want this on for the top.
Oh, I know what I did wrong. I'm an idiot. It's because I didn't connect this to the capture card.
Well, hopefully that.
There we go.
Oh,
now we're good. Sorry, that was my fault. I just brain farted there.
Oh, perfect.
On me. My bad.
All right. Do we need to do a dry run? Make sure that the stream is happy.
Audio should be working. It's going to go through your laptop mic. The only
through my laptop mic
or through
the podium.
Yeah, that's
okay.
Yeah.
Okay. Like if it's my laptop mic, that is the worst idea possible.
Yeah,
that's the worst laptop mic in the world.
That's already set up. It's just if you have audio in your presentation for whatever reason.
No. Oh no, my Rickroll on slide 37.
Okay. I'm gonna run to the bathroom real quick. Be right back.
Do I need to wait for you to start?
No.
Okay, I'll start at 20.
You go with that bathroom. All right.
The button has been mashed in OBS.
Wonderful. Okay. And you know about these are your microphones?
I don't know anything about anything.
Okay. These two little dots here are your microphones. Those are what go in the final recording, so please try to make sure that these microphones hear you.
All right.
If people ask questions, please repeat the questions because these definitely can't pick up the crowd.
Absolutely.
What you have now is live. Thank you.
All right.
And then I will give you a 10-5 2-minute warning.
I'll have a countdown on my thing here as well, so I will definitely on that. Might be a little over, but I'll be in control. I'm showing about a couple minutes till it starts, so thanks y'all who are here. Those on the stream, I'll get started right at 20 minutes after the hour, so that folks who are getting here right on time will have time to get here. Everyone having a good time at the conference so far? Kind of wrapping up. It's kind of weird, probably even for a 2-day conference. Like you sort of get to the last sessions and you start dragging. Even like if it was a 4 or 5-day conference, you still get the we're ready to. Maybe it's just because I got the talk slot at the end this time.
Not quite the closer.
Oh no! Anticipation is my least favorite of the varied human emotions. Not a fan of that, but. It's fine. We're all going to talk about it together. Setting your expectations, which be relevant for our chat here. But I'll go ahead and get started. So this is Trust in Open Source Communities. This is SeaGL 2023. Thanks for coming. I'm keeping a long-held promise to a friend that I would finally do a call for papers here and get involved in the local tech community despite living in Tacoma and working in open source. Well, working in open source longer than I've lived in Tacoma, but I've been doing it from Tacoma for 6 years, so I apologize for my tardiness in somewhat joining the local tech community, but let's get started a little bit. I do want to get in a little bit of background. I usually will skip this slide, but I feel like it's important in my perspective here. Today, I'm the Ironic Project team lead. I'm chair of the OpenStack Technical Committee. And I'm a Gen 2 contributor. My employer, G-Research Open Source Software Team, they really enable me to go off and work full-time on upstream OpenStack with really little interference. It's a pretty good deal. I appreciate them giving me the opportunity to speak here today. But you know, my start out was that I'm self-taught. Didn't go to college for tech. I actually flunked out of college. And the only reason I'm here talking to you today is because those open source tools existed I was able to teach myself, how to run an Apache web server, how to run MySQL, and got a job as a system admin using those tools, worked my way up, learned how to do DevOps as that became a thing, and eventually, did the work I do now as a cloud developer automating systems. And so this really impacts how I look at open source software, and we're going to hit this as we go through today. I'm an operator, no matter, what happens to me, that's how I think about the world. So we're going to talk about trust a little bit today, and I'm going to warn you ahead of time, the title's total clickbait. I'm not going to talk about anything juicy. This is actually going to be a pretty meaty talk, and by that I mean we're going to talk about the details. We're going to get in the nitty-gritty, and Oxford English Dictionary is going to start us out by saying that trust is reliance on some quality or attribute of a person or thing or the truth of a statement. Actually says about 2 pages on trust. This is the line that fits my narrative, so I picked it. So I'm breaking it down. So trusting a person or thing requires basically 2 bits for purposes of my talk. We have to have positive attributes, qualities, or statements, and then we have to really want to rely on those statements, attributes, or qualities. So it becomes a thing of like, here's a bunch of stuff we want, and we rely on it, and that trust is broken if that reliance is broken, if that foundation will build on cracks. Okay, so let's talk about what's not. Let's scope the talk a little bit, what we're not talking about. We're talking about what I'm going to call a professional approach of trust. We're not talking about the emotion. We're not talking about the gut feeling. We're talking about taking a risk management mindset to evaluating what you want out of an open source project, figuring it out, and minimizing the risk that you're taking when you pick one. We're talking about how that is shades of gray. That there's never going to be an open source project that you're going to say, this is perfect for my needs, or this is terrible for my needs. Nothing's ever going to fully meet your expectations or fully, dismiss all your expectations. There's always going to land somewhere in the middle. And the key thing, if there's only one thing about this talk you remember, it's a trajectory, it's a journey, it's a course plotted over time. It doesn't matter where they are today. It doesn't matter how many stars they have or how many commits they have. It's a matter of where were they in the past, where are they going in the future, and does that trajectory, match where you want to go? And that's really the key, right? Does it match where you want to go? So let's put on an operator hat, right? We're going to put on a few different hats. This is my operator hat. Going to pluck it on. And so as an operator, if I'm going to pick an open source project, and I've got to have reliance on statements or things that I got to know what I value first. I can't just start out and go look at what these projects value. I've got to know what I value, what I want. I've got to introspect a little bit first. So let's do that, and let's start out with use cases, because use cases drive your expectations. And, it doesn't really matter what your use case is for purposes of this talk. We're talking general purpose. You could be building clouds, or maybe just using them. Could be, just using your desktop to do your homework, or maybe you're hacking on a desktop trying to figure out how to get open firmware in them. Those are going to affect how you think about open source and how you think about the technology factors that impact the open source that you want to use. And so keep your use case in mind when you're thinking about some of these technology factors that you want to think about what you value in them. And this is going to be the highest level of overviews. I've cut a lot out of this talk. There's a lot of ground to cover here, so I'm going to breeze through this, but there's so much depth here that's getting missed. There are things like project philosophy that are technical factors. These are things like, are the APIs that you're going to interface with in this project stable? Have they had a history of actually keeping any stable API promises? Do they have concern for security? Do they respond to CVEs in a timely manner and encourage responsible disclosure? Or maybe do they sue people who do that? Those are things to do. See if they share your values about how to deal with security, how to deal with those API interfaces. What about their release model? Do they do releases? Is that something you need? Do you need stable releases where maybe if they have a bug and they fix it, you don't need to get all of those features at the same time? If that's something you need, if that's something you value, you need to internalize that. You need to think about that explicitly. And same thing with testing philosophy. Many people take it for granted these days that you're going to have CI and CD and everything gets tested on every commit. That's not true everywhere. Not everyone's going to share that value. Don't take anything like that for granted in stuff like this. Make sure that their philosophy about what technical things matter a lot in a project match up with yours. But it's not just about their philosophy, it's about what actually exists there. Now, obviously there's a baked-in assumption. Whatever your base problem is getting solved by some of these options you're evaluating, but there's stuff you might not have thought of that are actually based in the technologies that are used. Things like operating system or distribution support. Are you going to have to build packaging for it if you take it to your preferred OS or your preferred distribution? Is it written in a programming language that you have knowledge, or that your team has knowledge to troubleshoot in or to understand, or maybe even to hire people in if it's an obsolete programming language, perhaps? Their deployment methodology. If you're trying to take a cloud-native Kubernetes deployed, magic processing system and toss it onto your manually deployed enterprise Linux server, that's not going to be a good match. You're going to have a bad time. I mean, and you would think that's obvious, but that's the extreme option, and there's a lot in the middle there. And the other are just back-end dependencies, things like databases, things like what queue systems are being used, what infrastructure are you going to have to run to support this product, and does it align with yours? If you pick 3 different projects for 3 different pieces and they all want a different relational database backend, you've introduced significant misalignment to your system. And this is what it's about. It's about alignment. Alignment's the entire point. And it's about getting a head start. Because when you're thinking about trusting an open source community or project, it's about the shared technical values and getting a head start. You're identifying things that you have in common that you're going to want anyway that are already there. So let's take the technical factors, let's set them aside, let's look at some human factors. And I'm going to stay on the rocket ship with me here. We're trying to get through this in 20 minutes. So, human factors. If you're contributing to a project or using it long term, you've got to care how it's run. And why? Because you're going to be spending time there. So, one of the human factors, I could not think of a way to say this, so I labeled it as redundancy, diversity, and kindness. This is like the most human of the human factors when I think of it. Are there more than one core contributor? And I don't mean people. I mean, you should ask yourself this question. If one human or one corporation changed direction tomorrow, does that project still exist? Or does that project still meet your needs? And if that answer is no, and it's something that's critical to you or your business, that's something you need to know up front. They have a diverse contribution base, and I'm not even talking about the things that Deb addressed in the keynote. Go listen to her keynote if you want to do that. I'm talking about, does it look like your team? Is it a bunch of senior programmers who are a bunch of Linux geeks, and maybe you have some junior programmers who are also Windows people? Then maybe that's going to be a mismatch. Does that team have sort of similar backgrounds to people on your team? Are you going to share values when you interact? And that comes into the next piece of looking for positive interactions. And here's how I frame this is put yourself in the shoes of other people on your team, of other people who might be interacting there. If you've deployed this software to production, every person on your team who works with it, people who interact with you, people who hear you say, this is a good piece of software, might go interact with that project. If they go file a bug, are they going to have a good interaction with that maintainer? If they go to the community, are they going to have a good interaction, or are they going to get discouraged? Are they going to get treated rudely? This stuff matters. You don't want to be the reason why someone on your team or someone who's your friend has a really negative interaction because you didn't do some basic vetting. And then there's empathy for your use case. And this almost isn't even a human factor. This is almost a technical factor. Someone can be the nicest person in the world and just not care about your use case at all. And if they don't care about your use case, they're not going to merge the patches related to your use case, and it doesn't matter if you want to use their software or not. The other are less human and more licensing and legal. I'm not a lawyer. I'm definitely not your lawyer, but I work for lots of companies with lawyers, and they told me to look out for a few things. And some of that includes, for me personally, I care about OSI-approved licenses. I have certain things I look out for in open source licenses. You answer what you value in an open source license and look for that. But if you work for a company, they're going to have a list of licenses you can use. They're going to have a list of licenses you can't use, most likely. Have those conversations. Look that up. Don't get yourself in trouble. This is not a case of begging for forgiveness is better than asking permission. Go ask permission. The other piece that not a lot of people think of is trademark ownership and copyright assignment. How many APIs do you use that contain a trademark word of that open source project in the actual API spec? How many of them contain a command line client that you run that is the trademark name of the project? If that trademark is owned by a corporation, your freedom to continue using that is potentially able to be restricted by whoever owns that trademark. And similarly with copyright assignment, Doesn't matter what the license is. If you're assigning your copyright to a single entity, especially if that entity represents a business interest rather than like a foundation level thing, then it doesn't matter what the license is today. It could be something else tomorrow, and you're left behind on the old version. So this is all about protecting people. It's all about protecting business. Again, risk management. You don't want yourself, you don't want your peers, you don't want people who rely on you to have bad interactions and unexpected surprises because you didn't do your homework. So how do you do your homework, right? How do you evaluate these projects? Well, projects are going to communicate to you two ways. They have historical actions, they have documentation. This is basically it. The historical actions, I like calling them, these are like implicit promises. If someone does something every day, you expect them to keep doing it. Same thing here. If they do a release every month for years, you can expect they're going to continue releasing every month regardless if their docs say so. Same thing with CI coverage, giving you an idea of what platforms work. Active issue trackers, that bugs are getting opened and closed every day. You can have an idea. If I have to file a bug, it's going to get read. This is great. You see the actions, they're going to continue. The actions speak loudly. The thing that's bad about this is you don't know why they're doing these things. You don't know when they're going to change, if they're going to change, if you have that single contributor problem that we talked about a few slides earlier. So this has a lot of upside, but it has that pretty big downside. I'll note a little hack for this is ask politely for someone to explain their reasons or to maybe turn an implicit promise into an explicit one. And they would do that with documentation, right? Things like documenting an API that has backwards compatibility. Or one I've personally written, don't run this software in production, which a large number of people don't listen to. You would be amazed at the number of people who won't help running software in production that you have in the README, don't run this in production.
Fun though.
Or even code of conduct or governance docs, right? Where you're putting down and you're saying not just, here is how people are treated, you're saying, here's how we expect people to be treated. The upsides of this is that often if something's written down, it means that notice is going to be given if there's a change. There's an explicit process for doing that. And you can oftentimes look at Git or look at the discussions behind when those docs were written and get an idea behind why they're doing it and those motivations and using that again to kind of dig for values to see if those align with yours. The downside, and this is a big one, and the project I work on, I'll raise my hand, we're guilty of this a lot. Reality changes and the doc doesn't. The first thing that dies when a project runs out of time is that last step of updating a document. And so if you read a promise in a document and you don't see it backed up with the action, believe the action. So you get this process that kind of emerges, right? A loop. You determine and prioritize your requirements, you evaluate the candidate communities or projects, and you repeat it for every open source package used. This is great, this is easy, let's do it. Okay, so I looked at my hypervisor at home, got 624 packages. Let's do this. We're going to do it for ATSPI2 core? No, we're not. That's so much work. I love open source. I'm not doing this 600 times. There's a better way. We can outsource trust evaluation. We all know a guy in a maroon-colored hat or some like freaky, lime-colored lizard from Europe, or maybe a purple cow, or someone who we trust to package up software that we can sort of outsource the idea of trusting that to. Doesn't mean we can get rid of the whole problem. We've got to apply the same process, or else, maybe you'll be regenerating SSH keys or changing Linux distributions in the middle of a release cycle, if that trust is broken based on your evaluation. But you can avoid doing this a few times. So let's change hats real quick. Let's throw an OSS contributors hat. Now, y'all are all smart people. I'm not going to tell you explicitly how to transfer the knowledge to contributorship. I'm just going to add on. So there's some extra things you need to be concerned about if you're contributing. The first of all is an additional technical factor of contribution tooling. And this is how the actual code, the tooling that they use to go from, I want to submit a change to the change actually landing. And that can be, GitHub or GitLab PR style flow, something like Garrett, patches to a mailing list or other. The reason I mention this is that most projects are going to assume you know this. So you should know this up front. You should make sure you're familiar with the tools. If you're not familiar and everything else fits, take some time, learn the tools, it's fine. Also, if it's something weird you're not familiar with, ask the question as to why they're doing it, because knowing that answer as to why they're doing it is going to be another way to gain insight into what they value and seeing if that aligns with yours. There's also an additional human factor here of project governance. And I had about 10 minutes here worth of slides. That's another talk. Those have been deleted. I'm just going to say governance matters because if you're going to spend a lot of your life working on a project, you're going to want to influence how that project is run. And this entire talk so far has been about the values of a project, the sort of things that a project shows you that it does. And if you want to be able to set that for a large project, you have to be able to influence the governance. And that sometimes means it has to exist. Sometimes that means you just have to know the person who runs it. But knowing that you have an in to influence the project's governance is super important, as you'd want to influence anything you spend a lot of time in your life into. So, process comes up again, right? Figure out what you want out of this. Figure out what your requirements are, what you're valuing. You know, are you trying to learn something? Are you trying to get your name out there? Why are you contributing? Evaluate the projects and get contributing. As a senior open source contributor, I'm going to tell you this as directly as I can. Don't spend your time somewhere unless you're treated professionally. Even if you're a junior contributor, if someone's not reviewing your PRs respectfully, if someone's not giving you time, if they're not even providing you the basic level of asynchronous mentoring, spend your time somewhere else. That's just as plain as I can tell you. Not every project is going to be that way, and you deserve better. So, just to say that as plain as it can be, harshness is not a requirement of working in open source. So, okay, taking the contributor hat off, throwing it away, we're going to put on the business suit. Business people don't wear hats, they wear suits. So we got our business suit. And we're going to talk about leadership and curating open source projects a little bit here. And this to me is about documenting your values explicitly. This stops being about thinking about what they're telling you and it becomes about you setting the agenda. If you're responsible for an open source project, if you're stewarding an open source project, then you're the one who needs to write down what your support life cycles are. You're the one who needs to write down what your testing philosophies are. You're the one who needs to write down a code of conduct and enforce it to protect your new contributors. You're the one who needs to think about what the future-looking vision is for your project. Where's it going to be in 6 months? Where's it going to be in a year or 2 years? So when that interested operator, when the interested people who want to invest time and money into your project come along, they can look at your vision and say, that's my vision too. And they can join you along for the ride. Some of this also includes not doing the wrong thing. Like you can do the right thing, you also got to not do the wrong thing. And a lot of that's not making promises you can't keep. It includes a lot of saying no and a lot of not saying yes, which is hard. The ones I want to specifically point out are being aware of implicit promises you're making via your historical actions, and maybe saying, we're doing this, we don't intend to do it forever. If that's the case, just saying unfavorable license changes, reset all your goodwill. So if you ever decide to do that, just know you're hitting the big red button. And to help out with the one contributor problem, if you're trying to bootstrap a project, document what happens if that interest is lost. And don't forget, even if you're the maintainer, you can outsource that trust too. And you do that by listening to the feedback from the people who are packaging or deploying your software. And quite frankly, if you can do something to make someone's life easier who's packaging your software, who's helping to create that buffer between you and your users, you should do it. It ain't always going to work. You know, good luck getting, a Red Hat maintainer and a Gentoo maintainer to agree on the same way to do something. You're going to have a lot of trouble, but you should try. Right? Like these are people who are trying to help you and have a different perspective than you might have. So, in summary, trust is about risk and expectations management, not about a gut feeling. And that you've got to start out by understanding your values to set up a yardstick to measure the projects against to see if they line up to your values. Then you're going to look at that project's historical actions and explicit statements to evaluate those values and measure them against that stick you made earlier. And then you're going to pick the community that's most aligned with your values, both technical values, human values, and that meet your basic technical requirements for your best results. And if you're the one curating that community, make explicit statements about your values so that you're not only advertising them to the potential people who are interested, but you're setting expectations to your contributors. And that's my talk. If you've got any questions, I don't know if we have time, but I'm happy to take them here or outside. If you ask me a question or just say, hey, I like socks, you get a free pair of socks. I'm on lots of social media things. If for some reason you want a job in Dallas or London, G-Research is hiring. They're all into open source. And find out what G-Research open source software is doing. The link's there. I'm Jay. Thanks for your time.
Great talk.
Now, where's the nap room?
Yeah. for this testing.
Can I just plug in with
live.
Okay, should be good now.
Okay. You all want cute robot swag? I got stickers and magnets and buttons and stuff up here. All right, well, thanks for having me back. This is my 7th time presenting at SeaGL. And yeah, it's great to be back in person with you all. So what is orchestration? The ability to target systems and take action. It's as simple as that. Coria does this through using a message bus. Is anyone familiar with message queues, message buses? Yeah, and so some ones you may have heard of, MQ, ActiveMQ, Amazon SQS. But let's just demonstrate how a message bus works. Who is wearing glasses? Raise your hand. Okay, so my voice is a message on the bus to which you are subscribed if you're listening to me. And your response was based on a filtered match. You all got the message, and only some of you, and just the ones wearing glasses, good job, like raised their hand. And so that's essentially how a message bus works. We're like putting messages out, you're listening to them, and then it's up to you to say, hey, do I match that criteria? I'm going to go do something. So going back to ability to target systems and take actions, Coria embeds NATs as the middleware to handle the messaging. This means no SSH like connectivity is needed, no ports like need to be open for your systems, as they will initiate connections out to get the messages. Because it's embedded, you don't have to learn the ins and outs of running a middleware system, which makes it way easier to use. Who's ever used Ansible or Puppet Bolt or PSSH or SSH in a for loop? Right? So all great ways to do orchestration. You have to supply a inventory list, right? Like you have to know, well, like what are the systems I'm going to connect to do this thing on. And so that means it's up to you to figure out which systems you should target and collect their host names. And since we use a message bus, we can let the nodes figure out if they're in scope for our change, right? Like I didn't have to go do some search to see who was wearing glasses and then put them on the list and only talk to them. You know, I could just announce it to everybody and the right things happened. We can do this with Coria based on Puppet classes or small bits of code known as facts, or writing software in the language of your choice. You can do things like all systems in dev and in US West 1 that are also MySQL systems and in the finance cluster. Oh, and I only want the ones we tagged as canary, right? Like, however you want to like put it up and like differentiate your systems. Or maybe there's an orchestration task you want to do on just like, I'm going to have things in different groups like A, B, C group, right? And I'm going to do it over here first, or you do canaries and go from like the one node in your cluster to 10 to 100 or something, right? Like however you decide to chop it up, you can target and then take action. So let's just show this, and I have to change how my screen works, so let's see if that works.
That's up, yes. Sorry.
And
all right, cool.
That large, okay. So we'll start with just Coria ping. So this is going to show me what systems are listening on the message bus. So this is what's in my collective. So I'm running 3 VMs on my laptop here. I can do things like show inventory. And so I can go get inventory for a specific node and see info about it. I can see what automation things I can do to it. I can see the Puppet specific classes, but there are things I can also tag on. And then I get just a bunch of facts about the system. And I can use this to filter information more. show here. So let's do Query of Facts. And I want to show, let's just Query of Facts role. So I have information set about what the role of my system is. And so here I see I have a Puppet server and I have two things called managed, whatever that means. If I wanted to be more verbose, I could see, well, which hosts are which. And so we see this is found one time. Then I have these two managed roles. I also have things like environment. I could do more filters, so facts where role equals managed. Let's try that again. Not facts, I'm gonna find things. Live demos. So this is showing, is this like legible for folks? Let me move it up on the screen. So query a find, I want to find all the systems where I've got a key value pair and I'm looking for role that says managed. I see some subset of my nodes. I can go further and say, let's also do ones where the environment is in dev. Right, I'm going to show like one system there. Right, so like I can use this for targeting, so I can figure out, what systems do I want to like do a thing on. Even if you're not actually taking any actions, we find this really useful to just have real-time information. Like one of the things we have to deal with is like, how many RHEL licenses are we actually using right now? Like I can just go look, like how many systems are there. Or, do we have, it's just been identified that this software has like a CVE. Do we have it running? Oh, let's go look. And like, oh yeah, here's all the places. So now I know where to take action.
Is this in real time? So say Coria 2 is off right now. When you do the find, Coria 2 is not going to come back because it's not listening and responding?
Correct. This can also tie into PuppetDB as well as SeaGL, like other data, like there's like a plethora of like data stores. So like you could have it, I think, pull from a place that's not real time. Like you don't pull from some like data store that that data might be cached.
Yeah, so I guess my follow-up is, let's say you said, we found a bug in blah. All machines in managed dev, go and update it. And Coria 2 has been off for 2 days because I fat-fingered something. Is it going to update it when it comes back up and running tomorrow?
Oh, good question. So does it, is it configured to save its actions and like replay them? No. Realistically, you probably wouldn't like want that to happen because like you wouldn't want to like a big replay log because those things might not make sense when it does come back up. But yeah, I think if it did that up would be really.
That's why I'm asking.
Yeah, but no, it does not. Cool. So that's like targeting. Let's go back to the slides here.
I need to say gather windows to like get the. I'm gonna give it a second.
Oh, here we go. Yeah. Going from mirrored back to unmirrored for slides. Good times. Okay. So we did the targeting. We said orchestration is the ability to target and take action. So, all right, we can find things. This alone, like if you have the automation with Bolt or Ansible and you're like managing lists of systems to like run something against for like SSH, like the targeting alone is what provides a lot of value for me. Cool, and now we can take action. So there are different ways we can write code to actually take actions. The easiest way is to look for tasks on the Puppet Forge, but there's different ways you can write code here. Just like a quick look, like some of the most basic things and things you'll probably want to start doing with orchestration is like patching systems, responding to vulnerabilities, being able to do that, as well as dealing with like stateful systems. So if you're dealing with like different like databases and things, and so there's lots of tasks out there that are already geared toward those to get you started. Let's talk about security. So X509, like doing MTLS is the default. If you're using this with Puppet, it's like the easiest route. It just like sets up for you. The Puppet CA is used to issue certs, and only those holding keys and certs signed by that CA can connect to the broker. And so if you use Puppet, it like literally just works. You can also use Kubernetes cert manager. So if you're running a broker, like using our Helm charts, that broker can get its certs at start time from cert manager, and then cert manager can also issue certs for nodes not in Kubernetes. And if you have another CA, and if you have any CA in your organization, you have 5, you could do that. I wouldn't. But you can, and if yours is nice enough to at least have APIs and stuff, this can generate its own CSRs, and you can submit them to your CA and do the PKI dance. If you don't want to do all that, you can use JWT tokens. They're available. They're not as well supported, so it's not like the go-to. The Coria does have some support, but I don't think like all features are all like have like parity and everything. But cool. So let's discuss a practical implementation of this with CI/CD. Concepts here. Here we go. So here's like an architecture slide. So Coria is a client-server model. The server exposes a set of APIs that lets the client instruct them to take action. This communication is all done through the middleware broker, which is the Coria broker at the center there. Coria server is just a node controlled by a Coria client. Each of your servers would run an instance of the Coria server, and these servers host agents that make up the APIs that the server exposes. So these could be things like package, service, shell, like whatever, and then you can write your own agents. Each agent has actions, and so there is the package agent, and so the package agent can do things like install and uninstall and update things, right? And so you could also write your own agent that's like, update my app, and then do all the things that you do in your orchestration and dance for how you take your app up and down and check that it's healthy and all that. So let's take a look at clients. And clients are where you run the commands. A client's any software that can request servers to take some action. This is generally done through the MCO and Coria commands. There's also a rich API allowing you to write automated systems in Ruby and Golang, if that's your jam. The client has its own unique SSL cert that's typically signed by your Puppet CA. We talked about certs. At my work, we keep these short-lived and rotate them every month, like using Vault. So these are the certs that actually let you like run a command against the cluster, and so those are like these short-lived certs. And again, the clients don't need additional ports. Nothing will listen for connections. They make a connection out to the middleware and discover where the right middleware is using DNS server records. And so you set your SRV records to point to your brokers, and then the clients just work. Anyone using SRV records to do discovery? Let's take a look at the middleware. So again, all communication between client and server goes through the middleware brokers. This makes it really nice to use because you're not having to figure out all these like firewall ports and like deal with all that and wonder why it's not working or kind of working and sometimes working. The broker is really lightweight and performant. A 4 gig compute node, it can handle 50,000 servers. So like, yeah, it's not expensive to run in the cloud for you. All right, let's show the agents. Folks can't see this. Right. So let's do MCO package. That's an agent. And we see, yep, and we see I'm using MCO, and so here we see the agent can do things like install and all that. So let's have it.
Wait, what is MCO?
It's short for M Collective. Thank you. MCO package status curl. So this is going to go tell me about curl on all my systems. If I didn't have curl installed, it would tell me, you know, it wasn't found on so many systems. Again, this is meant to run on like lots of systems, so it doesn't just show you tons of output. But here, I see I've got 3 systems and they're all running the same version. Right. So now I want to, let's do the status and add some flags. So I want to say only on my managed roles and only in dev. Let's try that again. It works. I'm happy with that here doing the demo. So, all right. So now this is filtered down to one node, and I see what it is. So I'm going to update my specific role in dev and see how that goes. Hopefully better than the last command there. So curl has some like CVE, and I gotta go address it. It's done now.
Actually awesome.
Yeah, so it updated that system, or so it says. Let's just do status curl again and see what comes back. So now I have 2 on the old version, right, and 1 on this new version. So that system hasn't like fallen over yet. So I feel like comfortable. I've done some other testing. If I wanted to, I could put all this in a playbook and I could actually have it do a series of health checks and do retries and say, well, if this one's good, now I'm going to wait a little bit and I'm going to go on to the next one. I'm going to update in groups of 10 and I'm going to pause and check each time. So you can really start to layer how like your patching can get smarter and smarter.
What language is that playbook in? Is it JSON? Is it YAML? Is it...
The playbooks are written in the Puppet language, but then the scripts and stuff underneath them can be in like any language. Yeah. So you can write really just small snippet things and then have the part that does the logic in the language of your choice. So now I'm okay with dev. Let's update and prod. And another host got updated. I can see my Coria hosts are good and the system I'm on is not. I know you can't read this. Can you a moment here? It's like I logged into one of the systems, so you can see the release is actually the 59. Like, I'm not just making stuff up. I updated the system. We could do other things like let's show shell. So shell has different actions, so I can watch things and I can watch files and tail files. If seems crazy, but if you don't have other observability tools, that might be super useful. I'm just going to run like uptime on the systems. Right, but just to show you could go like do a thing and have it everywhere. Let's also do process list.
Could you have it run command on a bunch of servers running one OS and then run a different command on a different OS?
Yeah. So I could implement that in the agent to be more aware that way. I could also do filtering here. So just like I said, only on systems in dev. I could do other things as well. I'll get back to that. So here I just said show process list Ruby, and so it's just looking at like the process table on my systems and giving me the commands and the memory and stuff. So that could be useful. So you mentioned dicing it a different way. I could say, let's do. CentOS, and like the OS itself is actually like a big hash, so I can jump in here and say, well, only on whatever my CentOS 7 systems in dev, whenever, you know.
Do the servers, do they pull the broker waiting for things to do?
Yeah, they initiate the connections. Yeah, that's a important distinction for sure. Cool. So you can also do federation. And so you can have a federation of collectives. So here I have the location base. I've got London, New York, and Tokyo. They're completely standalone and isolated. So the central middleware acts as a management location where all the collectives are federated into one. And so the collectives, like London can't communicate with New York, but yet this client can communicate with everything. And so this can also be a way to be able to have separation between like dev and prod. Having them on different collectives.
Can you wrap it up? Sorry.
Yep. So the federation is easier to manage at scale. There's no shared infrastructure like console or databases or anything. There's geographic distribution which is great for like distributed systems, especially over problematic networks. And I'll show one quick playbook. And so here's an example of something where you might, like I showed very simple things for updating, but here say I want to do like blue-green deploys, and I want to be able to find all the systems that are on one side of the blue-green, and I want to like stop some service and restart things and update my app, and then, oh, by the way, run monitoring and make sure that's good, and then I want to do it in groups, and then I want to like tell some Lambda about it and tell Slack, you know, things are good or not. You know, you can start to build up, and that's where it really begins having value. So again, Cori is a great way to orchestrate your systems with powerful targeting and available agents. Check out Coria.io for documentation. And the VMs I was using is a Vagrant environment on GitHub under Coria. And so it's super easy. Vagrant up, you've got a whole system, and you can do what I just did. Any questions? Do I have time for a few questions?
We're running 5 minutes overtime. I just didn't
Okay.
want to cut you off halfway through.
All right. Well, thanks everybody.
If you have any questions, just ask them individually, I guess.
All right.
How does that compare with their certain applications?
Use OS where we're working now. Like, my plan is what's so strange? Well, it's just that we already orchestrated the orchestration piece as opposed to like OS quarter is giving us more like the hey, what's happening? But like since it all that for us, like the target is it's like, well, why run this other thing? It's like we getting its functionality is just a subset of this. So we're gonna.
Would you like miss out on like the queryability, like the SQL query? I haven't really used OS query, but it seems like the appeal is the fact that you can run those like SQL queries.
Maybe.
Yeah.
So you can have multiple nodes.
I think first it's more useful to know in like more real-ish time than like.
Versus waiting for it to all be collected. And, yeah, that makes sense. That was the thing that came to mind. That's why you want to use query. That more instantaneous.
Yeah.
It looks like it really relies on public infrastructure to make stuff like work.
No, it does just like work right out of the box. It's super simple, but like you can totally run it without. You can run it with your own CAs. You can run it with like Kubernetes, like
I see. The broker doesn't really have it.
No, it's just it already provides the API and does all that for you, and so it just makes it. It's like, well, we already have this, so that's just kind of done.
How does it execute public code without having a public master?
It does have. It can pull public code from a.
Oh,
sorry, you
right.
could.
Title
You
did
could
not
tell it to
mislead.
run it.
No. Have to.
Oh, okay. I think I've done that before. Yeah. Cool. Enjoy your talk.
It's the demo.
The demo?
Yeah, demo.
Yeah.
This is the talk, right?
It's actually programming like this.
I mean, GRP is cool and all, but well, they're actual Legos.
Yeah, I guess.
Yeah.
We got live demo today.
Yeah, so I'm gonna pass this around. If you want to like grab some Legos, and just kind of play with them, it's cool. It's kind of like it's all part of the experience.
It's like fidget toys.
Yeah, fidget toys. Like if you want to like zone out, since it's like the last talk of the day, like I don't know. There's like some instructions in there too if you wanted to try to like make one of the things.
He inspired.
Yeah, just grab some Legos and pass it on.
Yeah, there's an action to the community ecosystem.
There you go.
Wow, I have a feeling these are gonna get around.
So that's not, because I know packaging flavors,
Yeah, different things, but people run the same service.
Yeah, if you're coming in, there's a Lego box you can pass around. Please grab some.
No, they're all in.
Grab some to play with to make something.
Oh, no worries. I think I'll loop it back around.
I just took a face plate, deal with it.
No wheel.
Oh, here you go.
Oh, you got a wheel?
Also, to preface this, I totally thought I had the 50-minute slot, so we're gonna try to speedrun this. And also, if you want the slides, that QR code goes to the slides. I guess I can just start. Is that all right?
Yeah.
Sweet.
I already set up a
So hey, my name's Chris. My online handle is BreadChris. Trying to consolidate my brand. And the original title of this talk, as I submitted it, was "How do you build Legos for code?" But as I was writing the presentation, I really wanted to present how do you design Legos for code. So, the thing that I want to feel, I want coding to feel more fun. I don't know about you guys, but like sometimes it feels like a grind to like code on stuff, and you're just like, why does this thing not work? Like in my head, my mental model has this. Why are these things not like playing out as planned? And I wanted to feel like snapping Legos together. So that's why I need this tactile experience for everyone to have, because it's like this the very satisfying feel when you have these Legos clicking together. And you can build whole types of things, right? Like who here has grown up playing with Legos, played with Legos before? Yeah, absolutely, absolutely. We all know the feeling, and we love Legos. But we don't like playing with Mega Blocks. Why? Why don't we like playing with Mega Blocks? Their tolerances are just not as good as Lego. Like they don't feel good to play with. The plastic isn't as shiny. And so I've been playing with Legos for a while. My first Lego set came from a McDonald's thing. This was like back in 1999, I think, is when they had this line. And with a little imagination, you can like make it anything that you want to. And a few pieces became many possibilities, and that was kind of the whole mantra of Lego. You take these few pieces, rearrange them, see them however you want. And I wanted to create cool things with Legos. So, right, being a guy growing up watching Star Wars, I wanted to make Star Wars things, but a few pieces, you can only do so much. So naturally you need more to bring your imagination to life, and you need bigger and bigger sets, more money, because they're very expensive. My mom's here, she can attest to how expensive the Lego sets are. And what I always appreciate about Lego is you open these sets up and you have all the instructions, right? This isomorphic view of the thing that you're assembling, and the pieces are always accounted for. They always fit together. There's never any question as whether or not they fit, and it was always fun. You're always building something that's super cool, unless you accidentally drop it and all of your hard work is like there on the ground. So as you build these sets, you get confidence to venture from these things that you are putting together, and actually won a Montgomery County like state fair. My mom like cried when she like saw it like in the thing there. It was only 12 and under, so I don't know. But I love Lego. It's so much fun, and that literally was the bowling alley that I would go to and bowl, and I just had this idea in my head. Oh, I want to make that bowling alley, and so there you go.
With the grill.
Yeah, everything accounted for. But I did not like Mega Bloks. But why? Why? You see this in the store, and as a kid, it's like, oh, cool, they had a whole line with Halo. Like, you could get this. So why? Why in my head did I not think that they were good? And they were the cheap option. Like, their walls, like the walls of these Legos, they're smaller, they're thinner, they don't feel good to connect. And you can feel this when you hold them. I was also going to get some Mega Bloks to have a side-by-side comparison as we like held them, but close enough. And when you play with them, they're just not as fun because they don't go together. And like you can, as a kid, you can tell the difference. So this all is to say, we know when things don't feel good. We have this intuition about ourselves, and Lego just had this whole system beyond just the pieces, where they wanted everything to fit perfectly together. This is way back in like 1956. Like these guys had the vision to make Legos and make them all connect. And they invested time and money to make sure that actually took place. This is made over 120 million Lego bricks, this like one thing, and it's retired now. And the same pieces that were that existed back then still fit together today. That's literally the set that I got. I made sure to get that specific set. So everything, what you're touching right now, that's like a piece of history. It's the same, I don't know if it's technically the same plastic, but it's close enough, and it feels the same. So what about code? We have this feeling with Legos, where is that with code? And there is a bit of a thing here. It's like Legos aren't infrastructure. We don't build things out of Legos. Unless you're the Bugatti, what's the name of the car? Bugatti. Yes, thank you. And they made a fully functioning, that has a motor that moves, like insane. But yeah, the world runs on computers though, right? The world doesn't run on Legos, and they've changed over the years, so we have all these constraints that we're constantly dealing with. We've had to account for computers that take up whole rooms, and this is now Doom running on a birth control test. So anything's possible now with computers.
Wait, is that real?
What?
Is that real?
I believe so. Unless I got like internet scams with researching about it, but I mean,
how is that possible?
It's Doom. It's a computer. We proved that that's a computer. So what are the Lego bricks of the computer? If we have all of these constraints and all of this like historical kind of like grease that we have to like deal with, let's at least put our focus on like what are these building blocks that we build and use in our day. And depending on like what you've worked with, you might have seen different levels of this, but there's different levels that things kind of fall into. You have like machine language. I like to think of this as effectively the CPU. It gets like super small. These building blocks are like microscopic, and they're kind of like hard to play with, like with electronics. Like we can't get around it with like breadboards. Like I don't know if you guys know Ben Eater, phenomenal YouTuber, and he shows what is capable with hardware, and it's really phenomenal. But I don't know. I don't have patience for wires. I don't have patience for the multimeter, like tapping, listening for the beep. I want something that I can rearrange more easily. And so you move up from the hardware thing to now like assembly. So we're turning those ones and zeros into something that we're more like as humans capable of understanding. Really cool if you want raw performance. Like demo scenes, phenomenal. Those things are crazy. But they get complicated pretty quickly. You know, you're dealing with like floating point registers, and you're just like, what on earth am I looking at? So we need something else. What about programming languages? The next step up. And you know, there's a lot of different tools for different jobs in programming, and so we've come up with so many of these different things, and it's confusing. What do we choose? We have so many options. Why can't we just have one language? Why can't we just solve it with one? Right, that Lego, right? That one brand. So we could brainwash people into having this work, and that's exactly what Sun Microsystems did. This is like a full-on advertisement that ran on the TV, and it's like this like spy guy like saying, "Oh, what can run on Java?" And it's like, "Oh, here's your card. It has Java running it." Literally, everyone has Java in their pocket right now. Like, that's pretty cool. They got rid of brainwashing, and you know, maybe we'll rewrite everything in Rust one day. Like, right? We can dream, we can hope. But what if we make a mistake? Even if we brainwash everyone into like thinking like this, what if we made a mistake with the semantics? And we end up with 2 million downloads a month for a very simple task that needs like a whole module to solve it. I don't know if you guys are familiar. Is anyone familiar with Izod, the Izod package? Little niche joke. This is, if you want to tell if a number is odd in JavaScript, you basically have to download this package because there's so many edge cases. It's not straightforward, unfortunately. So what if the language changed over time, right? Okay, so maybe we make mistakes, maybe we need to change it over time. There's a lot of really cool tools like Racket, which is like based off of Lisp, that help us kind of write languages and solve it as we go. But at some point you need to commit. You need that blueprint, that schematic, that Lego like framework to get the network effect with languages. So where can we look for guidance? Who can we look for guidance to try to help us answer these questions? I personally really like these guys. Anyone? Who are these guys?
Ken and DMR.
What's that?
Ken and DMR.
Dennis Ritchie and Ken Thompson, OGs. What have they done? I don't know. Probably the coolest thing in history of like building like everything. Right? We started Unix, and now like my computer's running the stuff that came from them. Like if you have a Linux computer, literally anyone in their pocket, these guys wrote code that you're running right now. And where does this that power come from? And it really comes down to, in my opinion, the design philosophy behind Unix, and that's to write programs that do one thing and do it well. Right? Don't try to take on the world. Just focus on something simple. Write programs that work together, because ultimately all our phones are going to need to communicate with each other. So how do you make that happen? And write programs that handle text streams. So text streams are just like this general concept that everyone's going to have. If my phone wants to talk to your phone, that's a stream of effectively text. It's just bytes getting sent. The abstractions on top of that, we can talk about that later. So these guys, they didn't just invent Unix. They also had a hand in developing the C programming language, and then also Go, which we had the presentation just talking about that. So these guys have been around the block. They have really cool ideas, and I personally really like them. So, what we got? Sweet. Halfway through. Not even worry any halfway. Let's skip. Let's maybe do this. Let's do this. Learn a mental model, not a language. So, instead of focusing on language, I like to focus on mental models, because if we want to achieve what we have with Lego, we need to first conceptualize what that is. What does that feel like? And when you choose to go deep on a language, they kind of change the way that you think about stuff. And you need a language that's always there to anticipate your needs. If you're going to reach for something like a logging library, does that have it? Are you going to be able to get that? Or do you need to sift through whatever the logging library of the week for your language is? You don't want to deal with that. So Go, I really, really love Go, because the documentation for all of the libraries, it's very clear. If I want to read a file from my computer, I literally just go to read file. And another JavaScript joke here, if I want to go to read a file with JavaScript, I now am faced with the option of, do I want to use the promises or do I want to use the callback syntax? I don't want to deal with that. I just want to read a file, but this is a decision you have to make almost every time that you're dealing with JavaScript. So what if a language was so simple that there were not many of these pitfalls to really begin with, and it's always anticipated what you want to do? And Google had this specific problem because they have so many people. They have so many people working at their company. They need to develop something that's easily accessible for thousands and thousands of developers. And this is why Go was originally developed, to help solve some of these problems. And it's prioritized simplicity above all else, because when you just really focus in on like what it is that you're trying to do with this language and you want to like speak through it, you get a lot of really interesting effects. So one of the major things that I think goes completely under people's radar with Go is the fact that there's no package registry. It's just GitHub repos. In JavaScript, it's npm. In Python, it's PyPy. In C++, it's Conan. I'm not too familiar with it, but I've heard that that's like a thing. But these registries are an additional thing that you need to know about in order to access other people's code. But what if the modules are actually just the source code? And the Go language is a GitHub repo that you can just include into your own code and then start hacking off of it. You can just start it by including Go. And another thing that, I don't know, maybe people talk about this one, but the blog posts for Go are phenomenal because they are kind of like these like Confucius, like Zen things that speak about something that you have no idea what you're looking at the time, but you'll be coding like days later, weeks later, and be like, oh, that's what they're saying. And I highly recommend, no matter like who you are, what you're doing, I think that just reading these blog posts are actually pretty transformational. So there's also a lot of tools in Go that are just constantly anticipating. If you want to run a program, you say Go run. If you want to test a program, you say Go test. If you want to download a module, you say Go mod. If you want to benchmark, you say Go bench, format, build. All of these things, they're right there. You don't need a third-party library that you just have to know, like JUnit. Like you just have to know if you're writing Java that it's JUnit. That's not in the core Java thing, and it's like, what? Also, the type system, super simple. They have all these simple data types that are just the most commonly reached for data types. And again, I'm not trying to convince you to use Go. I think you might not like its error handling. Yeah, it's like a little wonky. It's a little different. You might not like its pointers. That might cause you some crazy no-pointer things. But at the end of the day, it's still very simple. There's always going to be these kinks in any language you use, but I've spent a lot of time programming, and I find Go to be like some of the most zen programming that I've ever been able to experience. And it helps you pay attention to that bigger picture. What are you trying to build? You don't always have to like create this most crazy thing. Do something simple. Legos have very simple connectors, and you connect those together, and it's like, oh, cool, that did something. Maybe it's closer to your goal. And yeah, just like with Legos, you have to play with these rules that they've just set. It's like you can't mold it together like clay. It's like you have to rigidly do these. But like we saw that like they've built cars, a fully functioning 1-to-1 scale car with Legos, so you can do a lot of really cool things. So this is a question to consider for you guys. Like, what languages do you use day to day, month to month? What are those problems that you face? Do you feel that like satisfying snap of like your code coming together, or do you find yourself get to just constantly death by 1,000 cuts, and you're just like so done by the end of the week that you don't want to do anything? Yeah, like ChatGPT helps a lot with this one, but we all still do it. So I like to think that types are kind of the foundation in the same way that Lego, you have those connectors. That's like the foundation. That's how you build your mental model around using Legos. And types are a way of communicating intent. If you want to, you show a kid these Legos, and it's like the Lego itself communicates how it goes together, because that's just what it is. And so as a programmer, you define your intent when you're talking to a computer. How do these types go together, and how do they run? And then the computer holds you to that. And it's also helpful for just communicating with other people, like how do you use your code, how do you interact with it. If types are too simple, they don't convey enough. This is my white space program that...
White space.
What does it do? I don't know what it does. It does something. If they're too complicated, they become incomprehensible, like for TypeScripts. If we wanted to write tic-tac-toe but not use any JavaScript, just the type system in TypeScript, we can totally do that. But why would we do that? Why should that even be possible? I don't know. But it is. It's perfectly possible. Sorry, another JavaScript. I'll keep going on that one. I still like JavaScript slightly better than Python, in my opinion, but up for debate. if languages had different type systems, how could they talk to each other? Oh, right. So we have all these languages. How do they talk to each other? We need to focus on like how do we get these things to go together, right? The Unix principle. How do you get them to talk together? And so I personally really like protobuf beyond anything else in this fact because it is simple but expressive. It again is a technology that came from Google, and you have to solve these problems when you have thousands of developers writing these programs concurrently with all these teams. How do they bring all that stuff together? I got to see this work at Uber. This is like the microservice mesh. There was like 2.5 services for every developer. So it's like, how do you get that to work? I don't know. gRPC. And so it's pretty simple. Like I think, I would guess if you're familiar with any type of programming language that you could look at this and make sense of it, even if you haven't even looked at protobuf before. Technically, this is also like gRPC, but I don't know. Like it seems pretty simple. Does it look simple? Who here is familiar with protobuf? Okay, so for people that aren't familiar, could you look at this and kind of like walk me through like what it's doing, like interview style? We don't have to do it now, but just like like yes, no. What do you think? People not familiar. Good? Okay, I think we're good, pretty good. All right, so it's also really cool. So protobuf has compilers for most major languages, and it takes your like proto file and then turns it into pretty idiomatic code for whatever language that you're using. And that's really, really helpful because it's kind of like anticipating you as a developer, what might you need with protobuf. You're going to need types for your language. Boom, there you go. And what I really like about this is you can have separated concerns. Once you've agreed on the contract between two people, and I'm writing the back end, you're writing the front end, we can build that independently once we've agreed on that type. And my code doesn't even need to be fully written. I could just send back mock data, and then there you go, we're implementing it. There are other things that solve this problem, but these are kind of like, in my opinion, like the mega blocks of this. A lot of really, really great effort and work has gone into this, but it's just like, I don't want to write this. Like that's effectively that same thing as protobuf, because it's just defining a type. It's the contract of how things go together. I don't want to be writing like double quotes the rest of my life. So, so now that we have types, and we've defined the types, protobuf. Let's say we're going with protobuf. That's the future. Now we need to do something with those types and transform that into other types of data. So, right, we need it to connect to other systems. So how do we achieve this? Typically, you might be familiar with like an ETL process where you have some data, you transform it, you put it into somewhere else. And that's kind of like foundational for most companies, most whatever that you're doing. And typically, the stuff which I find interesting, it's usually reserved for pretty boring stuff. Like pretty just like, oh God, I can't believe I'm doing that. But why? Like the question is why? Like I teach computer science like the high schoolers, and we use Scratch. And Scratch is, in my head, kind of like a workflow system. You have like events that happen, and then you like transform them. A little bit of a reach with that, but hopefully you get my point of a lot of code ends up looking like a workflow, however you define workflow, and I could be defining it pretty generally. But I saw at Uber like this system called Cadence. Now it's Temporal. They're a Seattle-based company, which is pretty cool. And they are a workflow manager that I saw scale really, really big. Uber had a lot of problems with scale, and Temporal kind of came in and solved those. But the way that the workflows are expressed with this, and this is super enterprise software, they're going to make their $1 billion company at this point. And the way that they kind of express these workflows, it's in code. And it's like, yeah, you know, like maybe I can understand this if I'm really familiar with Temporal, but I kind of want that feeling that I get when I'm in a room. I'm in a room communicating, how are we going to draw this thing? Or how are we going to connect all these parts together? I want a whiteboard. And I really like physical arrows to show like how data flows, how things are connected. And anyone familiar with this video? This is a phenomenal video. His channel is phenomenal, but it's like a whole bit about I'm at a company and I have all these services. Yeah, it's great watch. So how do we model these like physical connectors with a computer? And a lot of enterprises turned to BPMN, which is, oh God, like just enterprise to the max. Enterprise, not necessarily mega blocks, but it's just kind of like not fun Legos. They're kind of like metal. Like I don't know. I feel like it's just like yeah, I guess that goes together, but why? Yeah, it's just not that fun. And so, could we have something that's simpler, that's still more complete? And I don't know. These are kind of like questions that I still have, but I really like the idea of reactive programming. Kind of like this simple way of transforming data, and you might like map over some set of data, apply a function to that. And they're kind of like, I don't know, it's pretty intuitive, and I don't know, like, it's just some ideas that I have around this. I don't necessarily have the answers. And you can always build a workflow management yourself. A lot of people end up doing this. A durable queue will get you pretty far, like Cora demonstrated, like the power of that. And but if you build it yourself, what if you want to use it with other people? Like that's kind of like you can't, like, because you typically built your workflow system pretty bespoke, and maybe you started to like generalize it, but there's always going to be a huge slew of data. I really like temporal. That's kind of like my takeaway from this section is like if you're looking for workflow management, use temporal, but jury's still out. I want to make something better. And so that leads me to this, which has been the thing that I've been working on to try to improve this, called codename Protoflow. And we actually tried to build this before, and my co-founder Free, who's sitting in the front, we worked on this project that was kind of like it was in the browser, and there was these blocks. You could click on them. You could write like any code, and you could connect them together to kind of get that workflow feel. And it was unfortunately the wrong abstraction. So it was like tightly coupled with AWS, which is like just like really bad. Also, we had like multiple 10,000 line Python files, which just causes your computer to spin like whenever you open it up. And but the thing is, I kept coming back to this. As bad as I would like to say this was, I kept coming back to it because it really did kind of have that feel. It kind of had that like Lego feel, because you could write pretty much any code in any language. You could scale it because all of those code blocks were just lambdas, and you could share it with other people to use. And you had these things like pub sub database. That's the same thing. Who caught that? But yeah, because it was all built on AWS, you got these things that scaled, and you had all these other resources that you could have. And Protoflow is just kind of a continued effort. It's local first, because I really believe that this thing has to be local first. Also has to be open source. And this is, I almost didn't even want to include screenshots from this because it's like kind of confusing to look at. But we can zoom in on specific parts that kind of capture what my presentation had about this. And you had all of these nodes in there are strongly typed. So we have those protobuf gRPC definitions for services. So imagine this is like your code here, and you write whatever code you want. The thing that you're looking at, the protobuf, that's like the contract, the agreement with other people to look at it and use it. It also can run itself, which is like kind of funny. So Protoflow is the code itself, and it provides these methods like export project and new node, and you can like run them. So I've been starting to like rewrite Protoflow with Protoflow, which is like pretty cool. You can also change things together. Like this is how you build a Discord bot, which is like pretty straightforward, I feel like. And then like between read messages and write message, you apply like a map function to change the whatever message you want to like respond with. So maybe one day I could also build web apps. So this was like a prototype that I was putting together where like you have, I don't know if this makes any sense at all, but you have like a router has a route, and you have like templates, and then like if that route is like, let's say that's like /hello world, and then you hit that route from your browser, it templates all the response, and then it sends it to the response. Might be very confusing, but it's kind of interesting because it's kind of, I want to work towards this like visual builder of like a web browser or a web server. And the thing that like I find really interesting is like protobuf and temporal have solved problems for very big companies. Smaller teams need these tools in order to scale. And without the tools in hand or easy to get, like they're not going to benefit from it. And so really what I want to work towards with this is the fact that you could give like a senior developer's brain to like all these teams starting out, if they have these like really fun toys to just kind of like play with. And it's built on the shoulders of giants, so you can like scale. So parting words of wisdom, plumbers get paid a lot because pipes don't fit together easily. There is this Hacker News post that I saw talking about this, and it's just stuck with me in my head because it's like, yes. I don't know, have you guys ever like had to deal with like plumbing and like trying to find like pipes that fit together? There's so many different measurements, and it's like absolutely insane. And the point with this is like, we're all kind of like data plumbers at the end of the day. Like we might not call ourselves that, but we're moving data, we're doing that ETL like over and over again. And so we can continue to be data plumbers. There's a lot of value in that. But the thing that I want to specifically call out in this presentation is that we should really strive to try to build Legos for code. So it's not just these like frustrating pipes that don't fit together, but the ones that kind of like connect and they lock, and then boom, there's your plumbing. You can focus on the electricity for your house. So some ways to do this, if you have an idea of something you're doing over and over again, write a library. Maybe you need to write a framework. Maybe that problem's bigger than what you initially thought. And then eventually you're like, no programming language that currently exists solves these problems. Go make your own. Like you can totally do that. So yeah, it's like we're all in this room together because we like software. And we like building software because other people can use it. I don't know, maybe you're like Terry Davis. Or did he want, I think he wanted everyone to use God's computer. Holy see. But anyway, we're building the Legos for other people to use. Play with Legos, so that's why I brought some Legos here. Because I want everyone to like feel that feeling. And try to impart that in the work that you do. We have the ability to build these things. I think like it's worth it to try. And we also just know good things when we see them, right? Like you see something, you're like, oh yeah, that's pretty cool. That's a cool piece of code. That's a cool module. Try it out. See how it works. Look at the code. Maybe you can learn something from it. I also really like going to museums because they kind of teach us about like past mistakes, more often than not, but also the successes. And RIP, Living Computer Museum.
It's gone?
No, it's not gone.
Oh.
So I talked to someone, and they said that there was like a disagreement with Paul Allen's estate, and so they're not sure how to channel funding. But it's not officially closed. It's just like the funding's not there to actually open the doors. But if you haven't been, the Seattle Connections Museum, phenomenal place. It has fully functioning. It's like on the second story of a current telecom company. But they like, because telecom stuff is like so much smaller now, it's just servers and racks. They have the other floors which are dedicated to like old functioning machines. So you can stand there in the middle of like this like telephone switcher, and it goes with like the mechanical things like touching the leads that like connect you to the other line, and you can like make phone calls like inside of there. If you haven't been there, this is a phenomenal place, like absolutely phenomenal place. And at the end of the day, it's just connecting two things together. I really love it. So yeah, thank you. If you, I have some more stuff after this that you can scan this. It's a whole bunch of notes. I have a bunch of manic notes in there. I had to like kind of shove this down into like a presentable form, but yeah, you can keep going. Yeah, over? Ooh, am I in it or am I like 10 minutes over?
So we have time for like one question. We have to be out of this room completely in 5 minutes. So we can do like one question.
Sweet. Anyone got a question? Well, feel free to take the Legos home. Make sure you actually grab some if you haven't. But don't throw them away. I will know if you've thrown them away. What I would expect you to do is take them home. Put them on your desk, someplace that you can like visually see like throughout your day, maybe once in a while, and just try to remember that feeling of like connecting them together. Just like ponder on it. Have I experienced this lately? Where have I experienced this? So, yeah.